it boosts our confidence in conducting many more such events. And we also have data structures lab, alone only lab, coming 17th, 18th, and 19th, because again there were so many inquiries for data structures lab. So if you have any of your junior friends or your siblings in third semester, you can also tell them that there's a data structure lab crash course on 17th, 18th, 19th. Each of the experiments will be dealt in detail. It is going to be taken care by Professor Nandita Bangeda. Okay, and regarding this workshop, I again tell you all, make use of Miss Devi Navina and Jivita ma'am. They are very student friendly. They will clear any of your doubts. Please feel free to get your doubts cleared and come out with very good marks in your subjects of external exams. Okay, I wish you all the best for your ensuing examination and do well in all the subjects and also in ATC. Over to Professor Devi Naveen ma'am and Professor Jeevita ma'am.
Thank you, ma'am.
Thank you all. Thank you
Thank
all.
you.
Thank you, ma'am, for your introduction.
Thank you, Lata, ma'am. It's a great pleasure to conduct an online course on automata theory and computability. Uh, all the participants, welcome to the online crash course on automata theory and computability. Since this is a crash course, okay, and we'll be teaching you the important concepts which is required for your exam from each module, okay, with 2 3 problems as an example we'll teach you in detail. So if you know the logic very clear, if you understand the logic very clear, it will be useful for you in the final exam to solve any kind of problem. So we are here to teach you the logic of each and every module. Please keep a rough book with a pen next to you, so that whenever we tell you some important points or whenever we tell you to note down, you can note down. I surely, like, I'll tell you, if you listen to all the concepts what we both are going to teach you today, if you remember all these concepts, 100% you have prepared for your final exam. Okay, so whatever we teach, that is more than sufficient for your final exam just to go through. So please try to concentrate and understand what we are going to teach. Welcome to the crash course on ATC. Let us start with the first module. Let me share the screen. Myself, Devi Naveen, working as an assistant professor in the Department of Computer Science and Engineering from AMC Engineering College. See, the topic for today is crash course on the automata theory and computability, which is our 18 scheme. 18 CS 54 is a subject code. And these are all the contents what we are going to teach for the today and tomorrow's. Module 1, we have a DFA concept. Under DFA we have a pattern recognition problems, a divisible by k problem, string length mod k problem, string length mod k problem with relational operator, number of specified symbols mod k problem, number of specified symbols mod k problem with a logical operator. Okay, and NFA conversion, that is converting a given NFA to a respective deterministic finite automata, converting a epsilon non-deterministic finite automata to a deterministic finite automata, how to minimize the given DFA, and what is the concept behind the finite state transducer. Under that we have a Mealy machine construction and Moore machine construction. See, definitely from the first module, you'll be getting one question out of the DFA construction. Like we have 6 types of problem here. So out of those 6 type of problem, you will be getting exactly like one problem. You may get a normal NFA to DFA conversion or epsilon NFA to DFA conversion. That one question you may get in the first module, and minimization of DFA. Okay, and there is a less chance of getting a finite state transducer. And these are all the contents what we are going to teach from the module 2, that is regular expression, how to construct a finite state machine from the given regular expression, how to construct a regular expression from the given finite state machine. That means finite state machine means a DFA transition diagram will be given. By looking at the DFA transition diagram, how to construct a regular expression, and the reverse of that, you will be given with the finite state machine. Okay, you will be given with the finite state machine, and you need to write a regular expression. If regular expression is given, you need to construct a finite state machine. That is the first topic. And we have some different types of languages: type 0 grammar, type 1 grammar, type 2, type 3. And this is the most frequently asked question in the final exam. Definitely you will get a question as explain the different types of regular grammars. So obviously it will be asked for 6 to 8 marks. And the next topic is converting a finite automata to a grammar to a regular expression. See, all these concepts we are going to see under the module 2. Okay. Module 3 is, these are all the topics what we are going to see. Okay, we'll see when we go for the module 3. And module 4, we have a Turing machine concept. Module 5, it is full of theoretical concept. So we'll try to cover this also, variants of Turing machines, different types of Turing machines what we have. Okay, now we are going to once again. See, I'm just going to start with the first module, that is a deterministic finite state machine. It can be called as DFSM or deterministic finite automata, DFA. Generally, we call the finite automata. Okay, finite automata is the first module. Okay, under the first module, we have a deterministic finite automata, we have a non-deterministic finite automata, everything we have. Okay, we have a deterministic finite automata and the non-deterministic finite automata. We'll start with a deterministic finite automata. See, before going into that, finite automata is a deterministic finite automata is a type of finite automata. Why we call this as a deterministic finite automata means, uh, when you are going for constructing a transition diagram, you will have a number of states. And you will be able to find out on processing a particular input symbol. Once again. Okay. When you're processing a particular symbol in the transition diagram, you will be able to find out on processing a particular input symbol, machine is moving from which state to which state. Okay. Machine is moving from which state to which state. So that information you will be able to find out in the deterministic finite automata. That is, you're going to say from which state to which state the machine is moving on processing a particular input symbol. That clarity is there in the DFA. Okay, and that is why it is called as deterministic. You will be able to determine where to where the machine is moving on. So it is called as deterministic. Why we call it as a finite means, in the transition diagram you will have some number of states. You will be able to count how many states are there in a particular transition diagram. So since you are able to count the number of states present in the transition diagram, it is called as finite. Okay, you are able to determine on processing particular input symbol from which state to which state that machine is moving on. That is why it is called as deterministic. Along with that, you will be able to count the number of states present in the transition diagram. So it is called as finite. So together we can call this is a deterministic finite automaton. Okay. See, the formal definition, if you want to give us a formal definition, see, this is a formal definition. See, DFA can be defined with a 5 parameter. We can call those 5 parameters as a tuple. Okay, so DFA is a 5 tuple parameter, or it can be called as a 5 like 5 parameter machine or 5 tuple machine. What all those 5 parameters means I have given. See, a finite automata, we can call it as a abstract machine. The abstract machine is given with the letter M. M indicates machine. Okay, it is a 5 parameter machine. What are all those 5 parameters? So the first parameter Q is set of states. Okay, set of states, the number of states what you're going to use it in the transition diagram. And the second parameter is set of input symbols what you're going to process. The third parameter is transition function, that we call it as a del. Okay, Q naught is the start state of your machine, and F is the final state of the machine. That is what I have given. Okay, and graphical representation of the DFA. The graphical representation of the DFA means, see, you will be using the circles to represent the states. Final state will be represented with the double circle. Normal states will be represented with a single circle, and all the states will be connected by an edge. Okay, connected by an edge. Those edges are called as transitions. Okay, states are specified in the single circle. Only the final state will be represented using a double circle. Each state in the transition diagram will be connected by a line called edge, that is called as a transition between the states. Okay, now the first problem, why this is happening, the first problem what we have is pattern recognition problem. This is the first type of problem for which we can construct a transition diagram, or for which we can construct a DFA. So under the pattern recognition problem, the first question what we have is, I'm going to teach you how to construct a DFA for different types of problems. The first type of problem is pattern recognition problem. The question is, obtain a DFA to accept strings of A's and B's having a substring AAB. This is the first question. Obtain a DFA to accept strings of A's and B's having a substring AAB. Okay. Always when the question is given, find out what is the condition specified in the question. First find out what is the condition specified in the question. What is the condition specified in the question? It should have a substring AAB. That is the condition. So always when you're constructing a DFA, find out what is the condition specified in the question. Okay, the condition what I have is the string should have a substring AAB. This is the thing. Okay, so okay, so in the substring AAB, how many symbols are there? The substring AAB is a minimum condition. I can call this is a minimum string. In the minimum string AAB, how many characters are there? 3. That is, A is first character, second A is second character, B is the third character. So if you have 3 characters in the minimum string, you need to have a 4 states. You need to have a 4 states. That is, if 3 characters are there in the given condition, that is in the substring, I have a 3 characters. If you have a 3 characters, you need 4 states. If you have 2 characters, you need a 3 states in your transition diagram. If you have 1 character, you need to have a 2 character. That is, number of characters present in the given condition plus 1 extra. Okay, so since I have a 3 characters, 3 plus 1, it will be 4 states I need. So I have taken the 4 states. Okay, so Q naught, always the machine starts from the state Q naught. That is a start state of the machine. So I have taken 3 is the minimum string length. 3 plus 1 will give the number of states required in the transition diagram. So I have taken the states Q0, Q1, Q2, Q3. And Q3 is the final state. You can see the states are represented with a circle. The last state alone is represented with a double circle. That is the final state of the DFA. Okay. Now, after having four states in the transition diagram, all these four states should be connected by a line. That is called transition. I have just connected. Q naught is having one incoming edge, but there is no source. So it is called as a start state. This is called as a start state. And Q naught, Q1 got connected, Q1, Q2 got connected, Q2, Q3 got connected. So after connecting all these four states by a line called a transition, you have to write the minimum string. That is, the condition present in the question is substring AAB. This AAB is a minimum string. These minimum string characters should be written on the transition. Start state is Q naught, accept state is Q3, that is a final state. The first character in the substring AAB is A, that I have written it on the first transition. Second character is also A, I have written on the second transition. Third character is B, I have written it on the third transition. So this is the minimum DFA. Based on the condition given in the question, I found what is a minimum string. Minimum string is AAB. Three characters are there in the minimum string. So I need 3 plus 1 number of states in the transition diagram. So I have taken of 4 states. Okay. All the 4 states got connected by a arrow mark. That is called as a transition. Q naught is a start state and Q3 is a final state. I can call it as accept state also. It is specified in terms of a double circle. In terms of a double circle, and I have written the minimum string AAB on the arrow marks. Okay. Now this is called as minimum DFA. Our DFA is not yet over. This is called minimum DFA. So now what is the next procedure means? You have to process each state one at a time. Okay. Let me proceed with the state Q naught. Let me proceed with the start with the state Q naught. Now Q naught on A, you have a transition to Q1. Okay. Q naught on A, I have a transition for the input symbol A to the state Q1. For which input symbol you don't have a transition from the state Q naught. From Q naught, I have a transition for the input symbol A, but I don't have a transition for the input symbol B. Okay, because the string should have the combination of A's and B's. Okay, from Q naught, I don't have a transition for B. Whenever you don't have a transition for any input symbols, two things you can try. One is try giving the self transition for the input symbol for which you don't have a transition. Second, if the self transition is violating the condition, what is the condition? It should have a substring AAB. By giving the self transition for the input symbol B on Q naught, if you violate the substring AAB, you cannot give the self transition. If self transition is not possible, you have to go for giving the reverse transition. Okay. Always reverse transition will be given to the previous state which has a self transition for the same input symbol. That also you need to give without by checking the condition given in the question. Let us see. Q naught on B, I don't have a transition. Okay. I am just giving self transition for the input symbol B. Now, after giving the self transition on Q naught for the input symbol B, what will be the string I will have? You can see. Okay. See, if I give a self transition, it means that 0 or more times I can repeat the input symbol B. 0 or more times I can repeat the input symbol B. I have given the self transition for B on Q naught. Now, let us take one input symbol. See, I have taken W is equal to B, B, A, B. How I have written this input string means Q naught, start from the start state, proceed till the final state. Now Q naught, what is the transition I have? Self transition. 0 or more times I can repeat the input symbol B. Here I have repeated 2 times. You can repeat it for 3 times also, 4 times also. It is your wish. Okay. Now I have repeated for 2 times. Now this transition is over. Now what is the next transition? Q naught to Q1, I have the transition for A. I have written this A here. Okay. Now third transition is Q1 to Q2. I have a transition for A again. I have written this A. Q2 to Q3, I have a transition for B. I have written it at the end. So based on the transitions, what I have given in the DFA, I have written this input symbol. Now after writing this input symbol, Do you have a substring in the written string? Yeah. See, you can see AAB is the condition given in the question. That is a substring should be there. So even though if I give the self transition for B on Q naught, it is not violating the condition. It is having a substring AAB. It is having a substring AAB. That means you can see machine will be in the state Q naught. Q naught on first character B, where the machine will be, it will be remaining in the Q naught only. Okay. Now input symbol is second B. Again Q naught on B. Machine is in the state Q naught. Processing the second B. Again machine remains in the same state Q naught only. Now again process the third input symbol A. Okay. Machine is in the state Q naught. Q naught on third input symbol A, where the machine will move. Machine is moving to Q1. Machine is moving to Q1. Now machine is in the state Q1. Okay, machine is in the state Q1. Process the fourth input symbol A. Q1 on A, where the machine is moving on Q1 on A, machine is moving to the state Q2. Now machine is in the state Q2. Process the last input symbol B. Okay, Q2 on B, where the machine is moving on, it is moving on to the state Q3. Now, do you have any input symbol to be processed which is left out in the given W string? No. I have processed all the input symbols successfully. Now, at present, machine is in the state Q3. If there is no more input symbol to process, and if the machine is in the final state, that means that the DFA, whatever we have constructed, is proper. Suppose you have some input symbols left out for processing, and machine is in the final state, means it will not get accepted. That is not a proper DFA. The other case is there is no input symbol left out for processing, but machine is not in the final state. That time also DFA will not accept those kinds of strings. So since after giving the self transition for the input symbol B from Q naught to Q naught, it is not violating the condition. Even though if I give the self transition, the string what I get is BBAAB. The string is having a substring AAB. It is satisfying the condition specified in the question. So this self transition on Q naught for B is valid. Okay. Now from Q naught, I have a transition for A also. I have a transition for B also. Now this state is over. Now move on to the next state. Okay, Q1. Again from Q1. Okay, again from state Q1, I have a transition for the input symbol A, but I don't have a transition for the input symbol B. Try giving the self transition. Try giving the self transition. I give the self transition. Okay. Now, after giving the self transition, write down the input string. See, this is what I have written. First transition is any number of times I can repeat B. I have written two B's. I have written two B's. And next transition is having A. I have written A. Now again on Q1, I have a self transition that again I can repeat any number of times the B. I have repeated three times I have repeated here. You can see three times I have repeated. Now I have the next transition is A. Third last transition is B. I have written it. Now after writing the input string based on the given transition, do you have a substring AAB in the written string? No. Nowhere you can see the substring AAB together. That means these kinds of string will not get accepted by the DFA. It will be rejected by the DFA. Since I have given the self transition on Q1 for B, it is not having the substring AAB. So self transition on Q1 for B is not allowed. Whenever self transition is not allowed, you have to go for giving the reverse transition. So reverse transition can be given to any of the previous state. For Q1, what is a previous state? I have only one previous state, that is Q naught. I have only one previous state, that is Q naught. Okay, so try giving the reverse transition from Q1 to Q naught. See, always reverse transition can be given directly to the previous state in which you have a self transition for the same input symbol. Okay, now I tried the self transition for the input symbol B on Q1. It is not possible. So for the same input symbol I have to give the reverse transition. Now which is a previous state which has a self transition for B, only one state. This is a state which has a self transition for B. Okay, so what I will do is I will try giving the reverse transition to the previous state Q naught. Now, if I write the input string, you can see B I have written two times, A again, once again this reverse transition I have written B, again this I have not repeated, A, B. Based on the transition, you try writing the input string. After giving the reverse transition, I have written the input string is this. Now in this I have a substring AAB, so this is valid. Similarly, go for the state Q naught. Okay, sorry, go for the state Q2. From Q2, I have a transition for B. For A, I don't have. I'm just giving a transition for A on Q2 to Q2. So what is the input string I get? I get the input string as this. Try writing from the Q naught state. B, I have written A, B. Now, if I give the self transition for A on Q2, it will not violate the condition. It will have the substring AAB. Okay, you can see B, A, B. Okay, at the end you will have a substring AAB. So self transition for A on Q2 is also valid. Okay, now I'm moving on to the state Q3. Okay, on Q3 I don't have a transition for A also, I don't have a transition for B also. I'm just try giving the self transition. I'm just try giving the self transition for A also, B also. If I give the self transition on A or B, the string will be like this. See, for these two B's, machine will be in the Q naught. For this A, machine will go to Q1. For this B, machine will go to Q naught again. For this A, again it will come to Q1. For this A, that is second A, it will come to Q2. For this third A, it will remain in the Q2 itself. And for this B, okay, it will move on to Q3. For this A, that is the last A, it will remain in the Q3. For this last B, it will remain in the Q3 only. So you have a substring AAB in the written string and machine is in the final state Q3. There is no other input symbols left out for processing. Okay. So this is a complete DFA what you can construct for the given question, that is strings of A's and B's having a substring AAB. For each DFA what you construct, okay, you need to write the definition. Definition is nothing, the 5 parameters you need to write. See, machine M is a 5 parameter machine. Now in the constructor DFA, what is the set of states? Q0, Q1, Q2, Q3 or the states. I have to group it together. And what are all the input symbols I have processed, whatever symbols I have written it on the arrow mark, those symbols will be called as the input symbols. Summation is equal to A comma B, and start state is a Q naught, final state is a Q3. That is the definition what I have written it here. And I have to write a transition function. See, I have written Q summation start state and final state. Transition, that del symbol I have written it here. See, how to write a transition means, see, transition of Q naught on A, where the machine is moving on, Q naught on A, machine is moving to Q1. That is what I have written it here. Transition of Q naught on A, machine is moving to Q1. Transition of Q naught on B, where the machine is moving on, it is moving to the same state Q naught. Q1 on A, the machine is moving to Q2. Q1 on A, the machine is moving to Q2. Q1 on B, where the machine is moving on, it is moving to Q naught. Similarly, Q2 on A, the machine remains in the same state Q2. Okay. Q2 on B, the machine moves to the state Q3. Q3 on A remains in Q3. Q3 on B also, it remains in the Q3 itself. Okay, so this is the definition and the transition functions what you need to write for each DFA. I'll tell you, if you don't write this definition and the transition function, out of the given total marks, 2 marks will be reduced for not writing the definition of the constructor DFA, right? So this is an example for pattern recognition problem. This is a transition table. Based on the transition function, what you write, I have just written the transition table. States are Q0, Q1, Q2, Q3. Four states are there. In the transition table, the start state will be indicated with the arrow mark. Final state will be indicated with a asterisk symbol. Now, similarly, Q naught on A, the machine is moving to Q1. Q naught on B, the machine is moving to Q naught. Similarly, Q1 on A, Q1 on B, Q2 on A, Q2 on B, where the machine is moving on. That you need to write it as a transition table. The columns indicates the input symbol, rows indicates the state numbers, right? Now, see, the negative case, what I want to teach you is DFA to accept the strings of A's and B's having no substring. The previous example was having a substring. Okay, that is the positive case DFA. Now, second example is DFA to accept the a strings of A's and B's having no substring A, B means this is a negative case question. Okay. So when you want to construct a DFA for the negative case, okay, first you need to construct a positive case DFA. What is a positive case DFA? Construct a DFA which has a substring A, B. So this is a DFA what we have constructed to accept the string which has a substring A, B. Now, after constructing a DFA for the positive case, this positive case DFA should be converted into a negative case. It is nothing. What is the conversion you need to do means in the positive case DFA, Q0, Q1, Q2 are the non-final states, and Q3 alone is called as a final state. This is a positive DFA which has a substring A, B. Okay. Now to convert this into a negative case DFA which does not have a substring A, B means non-final states should be converted to a final state, and final state should be converted to a non-final state. So after constructing a positive DFA, change final states to non-final states, non-final states to final states. If you do this change, you will get the DFA for the negative case, that is which does not have a substring A, B. Now this is a positive case. Q3 is a final state. I'm just going to convert this Q3 into a non-final state, right? Non-final state, single circle. Non-final state means single circle. Now Q0, Q1, Q2 are the final non-final states. Let me convert that into a final state by including a double circle. Q2 is a non-final state converting into a final state. Q1 is a non-final state converting into a final state. Q0 is the non-final state converting into a final state. So whenever you get a question in the negative way, construct a DFA for the positive case, change final states into a non-final states, non-final states into a final states. There is no other changes. Transitions and all will remain as it is. Only the change of states will happen in the negative case. So this is the negative case. For each DFA, write down the definition. What are the set of states? What is a start symbol? What is a final states? And what is a transition function? All those things you need to write. Okay. See, one very important example which will be asked in the question paper is DFA to accept all types of numbers with optional sign. All types of numbers with optional sign. See, numbers can be a integer number, it can be a floating point number, or it can be a positive integer, or it can be a negative integer, positive floating point number, negative floating point number, number with exponent. The exponent may have a plus or minus symbol. So many options are there for accepting a numbers. Okay, so I will take one number example. So based on that, we'll see how to construct a DFA. Okay, the first number what I have taken is W is equal to 1 2 3 4. See, number, if I say, it is a combination of digits. Okay, minimum one digit should be there, maximum it can have any number of digits. To have a number, minimum one digit should be there, it can have any number of digits. So I have taken one integer number. W is equal to 1 2 3 4. Okay, so it should have minimum how many digits? If you want to have a number, integer number, minimum how many digits should be there? Minimum one digit should be there. Okay, minimum one digit. So what is a minimum number? One digit. So how many states I need? One plus one, two states I need. So what is a minimum string you need to find out? To have an integer number, minimum I need one digit. So how many states I need to represent a integer number? 1 plus 1, two states I need. Okay, so I have taken a two states here. You can see q0, q1 I have taken. Okay, so q1 is a final state, q1 is a final state, q0 is a start state. Okay, now after having a two states, these two states should be connected by a line called transition. Now q0 is a start state, q1 is a final state. After connecting, minimum how many digits should be there? One digit. Okay, I have written minimum one digit. Okay, okay, minimum one digit should be there to have an integer number. Now it can have any number of digits. Okay, it can have any number of digits. So q0 to q1 I have minimum one digit. It can be followed by any number of digits. See, one digit is here, it can be followed by any number of digits. So I will give the self transition on q1. If I want to repeat any symbol zero or more times, I have to give a self transition. I have to give a self transition. So minimum one digit I have given. If I want to have a zero digit or 10 digits, I need to give the self transition. So I'm just giving a self transition on q1. Okay, if I say for the first digit 1, machine will move from q0 to q1. Okay, and for the remaining three digits 2, 3, 4, machine remains in the state q1 only, because I have a self transition for d. Okay, so there is no other symbol to process in the given integer number. Machine is in the final state. So this is valid for integer number. Now let me take a number, that is signed integer number. Let me take a signed integer number. Signed integer number means it should start with plus or minus. Okay, the integer number may start with plus or minus. Plus or minus it should start with. Okay, so plus or minus means the minimum, it should have one operator, that is one sign. That one sign should be followed by minimum one digit. So how many minimum strings I have? Plus should be there or minus should be there. This plus or minus should be followed by one digit. So minus or plus is one digit, and it should be followed by single digit. So totally two symbols are there in the minimum string. So I need 2 plus 1, 3 states. I need 2 plus 1, 3 states. so so from q naught only I need to start. Okay, because it is a number. Okay, when I start with plus, always machines should start with a q naught only. So what I'm going to do is I'm creating one more state. See, plus is one symbol, it should be followed by one digit. So totally two symbols are there in the minimum string. 2 plus 1, it will be 3 states. Now q0 is one state, q2 is second state, q1 is third state. I need a three states for accepting a signed integer number. q0, okay, to q2, q0 to q2, q0 to q2, I will be connecting, and q2 to q1, excuse me. See, q0 to q2 I will connect, q2 to q1 I will connect. So these three states are for accepting the signed integer number. Okay. Now what is the integer number? It should start with plus or minus. I have given plus or minus. This plus or minus should be followed by minimum one digit, and it can be followed by any number of digits. So for plus, the machine will move from q0 to q2. For the first digit 1, machine will move from q2 to q1, and I have written one digit. And 2, 3, 4, it can have any number of digits, means already I have a self transition for q1 for the digit. So 2, 3, 4 will be processed on q1. Now this is the This direction is for accepting the signed integer number. Now I'll go for the next number, that is a floating point number. Okay, so floating point number means integer number should be followed by dot, and that should be followed by integer. Okay, how will you specify the floating point number? Means integer number followed by dot followed by integer number. Now already I have written the transition diagram. I have written the transition diagram for the integer number. So this is the transition diagram for integer number without sign. Q naught on 1, it will move to Q1. Q1 on 2, it will remain in the Q1 only. And this is the integer part of your diagram. Okay, this is the integer part of the diagram, and it should be followed by dot. Based on this example I'm saying, it should be followed by dot. So followed by dot means I will include one more state. Okay, followed by dot. Dot should be followed by a dot should be followed by, you can see, floating point number should start with one digit, minimum one digits, and it should have a decimal point. Decimal point should be followed by minimum one digit. So totally how many symbols I have told you as a minimum string? One digit, minimum one digit, and it should have a floating point, and that should be followed by one minimum digit. So totally 1 plus 1 3, 3 plus 1 4 states I need, right? So already I have a two states here, I need two more states I have included. So this will process the first two digits. Okay, and next it should be connected Q1 to Q3, Q3 to Q4, it should be connected. And on the first thing I'll have a dot. You can see this is the first integer part, this is followed by dot, and this should be followed by second integer part. Can you see? So first integer part already we have constructed. Dot I have used, followed by dot. That dot should be followed by minimum one digit, and it can be followed by any number of digits. Again I have included one more integer part. Now this is for the floating point number. This is valid for floating point number. If you have a signed floating point number, okay, this step will process. You can see Q naught on place, it will go to Q2. Q2 on the first digit 1, it will go to Q1. Q1 on second digit, it will remain in the Q1 only. Q1 on dot, it will move to Q3. Q3 on first digit 3, it will move to Q4. Q4 on this last digit, it will remain in this one. So this will be for integer, and this entire thing is for floating point, and this is for signed integer, and this is for signed floating point. Okay, now the next type of example is like, it may have a exponent also, that is integer number to the power something. Okay, so power will be specified with the help of e or e. Okay, now signed exponent with the signed power. See, even before exponent I can have a signed number, after exponent also I can have a signed number. I have taken signed floating point number followed by exponent followed by signed integer I have taken. Now you see which is a signed floating point number transition. You can see Q naught on minus, it will come to Q2. Okay, Q naught on minus, it will come to Q2. Q2 on first digit 1, it will move to Q1. Q1 on this digit, it will remain in the Q1. Q1 on dot, it will move to Q3. Q3 on this first digit 3, it will move to Q4. Q4 on 4, this is. So signed floating point number is this part. Okay, and this signed floating point number should be followed by what? Exponent symbol. Okay, so exponent symbol I need. See, exponent symbol, this is a exponent symbol should be there, sign should be there. Okay, and it should be followed by one digit. Okay, so I include four states: exponent, okay, exponent, sign plus or minus, it should be followed by minimum one digit. So three symbols, 3 plus 1 4. Now Q4, Q5, Q6, Q7, these four states I will connect it. Okay, now on the arrow marks I'll be writing E. Okay, on the arrow mark I'll be writing, it can be a capital E or it can be a lowercase e, that is followed by minus, that is followed by minus, and that is followed by a minimum one digit, and it can be followed by any number of digits I have given. Okay, so exponent symbol, it can be followed by plus or minus. Here I have a minus, so it will come to q7. To process this 2, it will go to q6. Q6 on 3, it will remain in the same state, q6. This is for signed floating point number with exponent and with the power with the sign. Okay, signed power. Now this is the thing. Now next example is a floating point number without sign. Okay, we have floating point, signed floating point number followed by exponent followed by just the integer number, unsigned integer number. So what is the this one? You can see this is a signed floating point number. Okay, this is a signed floating point number up to q0 to q4. It is a signed floating point number, and that should be followed by e. I have given, it will come to the state q5. Now q5 on 2, you don't have a transition. Okay, so what I'll do is like q5 to q6, I will connect q5 to q6, because q5 on plus or minus, it will go to q7. But after exponent, I don't have any sign. Plus also I don't have, minus also I don't have. So what I will do, q5 to q6 I will connect. I will specify minimum one digit. Minimum one digit for this exponent. It will enter into the state q5. Q5 on 2, it will go to q6. Q6 on 3, it will remain in the q6 only. Now the last example for this is, this is the thing. Okay, the last example for this is, this is the thing. Okay, now you see integer number. Okay, followed by exponent followed by integer number. Okay, what is the end of the integer number? q0 to q1. From q0 to q1, I have the integer number. Okay, for q naught on 1, it will move to q1. Q1 on 2, 3, 4, it will remain in q1 only. And it is followed immediately by exponent, means there is low link. So this is the end of the q1, is the end of the integer part. From the integer part, I need to have a connection to the exponent. So which is a state which has the incoming edge for exponent? Which is a state which has the incoming edge for exponent? q5 is a state which is getting exponent as the incoming transition. Okay, q5 is a state which has the exponent as the incoming transition. So from the integer part, this is the integer part, to q5, I will be giving the connection. Okay, so that 1 2 3 4 will be processed between the state q0 and q1. And q1, this e or e, it will go to q5. After that, I have a integer exponent 2, it will move to q6, and this 3, okay, it will remain in the state q6 only. Okay, now this is the integer number followed by exponent followed by the integer exponent number. Okay, this is the transition diagram for accepting the all types of numbers.
How to give self transition there?
See, if you want to give a self transition, I'll tell you, if you want to give a self transition, if you want to repeat, okay, if you want to repeat any symbol 0 or more times, you have to give the self transition on the particular state. For example, integer number, I have taken it as 1 2 3 4. Okay, integer number, what I have taken it as, integer number 1 2 3 4. See, number means minimum it should have one number. Okay, one digit it should have. So for that one digit, I have given the transition between q0 to q1. You want to repeat, see, number can be a one digit. It is not like it should be of 2 digit or 3 digit or 4 digits. Minimum one digit, if it is there, it can be considered as a number. It is your wish that that one digit can be followed by one more digit also, or two more digits also, or three more digits also. So for repeating this, other than the minimum digit, if I want to repeat the digits once again, that is 0 or more times, I will give the self transition on q1. Now see, based on this different examples, I have to decide where to give the self transition. Minimum 1 digit means I have connected q0 to q1, so it can be followed by 0 or more number of digits also. I have the concept for a integer number means on the final state I will be giving the self transition for the 0 or more digits. This is with respect to this particular example. But in the previous case, having a substring aab, that is a example what we have seen first. Okay, in that from each state you need to check for which input symbol we don't have a transition. Try giving the self transition without violating the condition specified in the question. If the self transition violates the given condition in the question, you cannot give the self transition. You have to try giving the reverse transition. So reverse transition, sometimes it works, sometimes it will not work. If self transition is also not possible, reverse transition is also not possible means you cannot process that particular symbol on that particular state at all. Most of the times you will be able to give the self transition. If not possible, give the reverse transition. If it is also not possible, don't give the transition for the symbol itself, just leave it, because we cannot process such type of symbol. We will not give the transition only for such type of symbols. Okay, next type of problem. See, under the pattern recognition problem, I have told you three examples. Having a substring, does not have a substring AAB, and you have the to accept all types of numbers. By taking all the different types of numbers, I just started constructing a DFA step by step. Similarly, if you want to construct a DFA, you also take a example string and you try constructing a DFA. Okay, and this previous example is very much important, because in most of the question papers I have seen like construct a DFA to accept all types of numbers with optional sign. Okay, so this is the thing. Next type of problem for which we can construct a DFA is divisible by k problem. See, only the pattern recognition problem will be little bit difficult, because logical thinking is required for constructing a DFA for the pattern recognition problem. If time permits, we will go for some more examples under the pattern recognition problem, because that you feel little bit difficult. Let us finish the first module. After finishing the first module, if we have enough time, I will teach you two more examples, so that you can understand in a better way. Okay, so second type of problem is divisible by k problem. See, this problem can be solved directly with the relation whatever I have written it here. Transition of state qi on processing the input string a, machine moves on to the state qj, where this j can be calculated using the equation j is equal to r multiplied by I plus d mod k. Okay, so if you want to solve this kind of problem, you have to remember this relation. If you remember this relation, you can easily solve this. Okay, how I can identify a problem as a divisible by k problem means, okay, I'll tell you with an example. See, DFA to accept the decimal string divisible by 3. Okay, divisible by 3 I have here, divisible by k I have. So if you have a divisible by 3, it means that it is a divisible by k problem. You need to remember what is a relation I need to use it. Okay, so decimal string means the decimal number base is 10. You know that, right? Decimal number has a base of 10. Okay, that means the digits what I'm going to process is decimal string 0 to 9 I'm going to process. Now in the written relation, qi is a start state from where the machine is processing, and qj is a state where the machine is entering into on processing a particular input symbol a. This j, okay, should be calculated using this equation I said. Here r indicates radix, that is base of the type of number. That is, if in the question if you have a decimal number, the base of the decimal number is 10. So that will be considered the value of r, that will be considered as the value of r. Okay, if in the question if they specify binary string, binary number base is 2, so radix of that kind of question is 2. If they say octal string, okay, base is 8, you need to consider r value as 8. So you have to find out what type of string they are giving in the question. Based on the type of string, you need to find out what is the radix, that is base of that particular input string. Since here I have a decimal string, the base of the decimal number is 10, so I have taken r, that is the radix of the input is 10, r value is 10. Now I is nothing but reminder of the problem. Okay, reminder, I indicates reminder. How to find out the reminder value means always the reminder value varies from 0 to k minus 1. Now here what is the k value? I have 3. Okay, so 3 minus 1, it will be 2. K minus 1, k value is 3 in the given question. 3 minus 1 is 2. So 0, 1, 2. Okay, these three values will be the reminder values. Okay, and d is a digit, that is decimal string, means it is a decimal number. 0 to 9 I have to process. Okay, digit indicates 0 to 9, because decimal string, decimal number means the decimal digits are 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay, so 9 digits I am going to process. Divisor directly you will get from the question. K value, k value is nothing but divisible by 3. Divisible by k, divisible by 3 means k value, you will get the value as 3. That is a divisor. Okay, so you have to find out radix based on the type of string what you have in the question. And I is a reminder, reminder value varies from 0 to k minus 1. K is a divisor what you have in the question. And d is a type of digit, that is number of digits based on the type of number. Decimal number means the digits will be 0 to 9. So k is a divisor, that you get it from the question. So the first question under this type of problem is construct a DFA to accept the decimal string divisible by 3. Now the moment they give the question, find out what is the r value, I value, d value and k value. That is the thing of what I'm going to do. Since it is a decimal number, decimal string, base of the decimal number is 10, so I have taken r value as 10. I have taken the r value as 10. Now I value, before that let me take the digits. Since it is a decimal string, the digits will be from 0 to 9. If r is 10, okay, digits will be 0 to r minus 1. If r is 10, digit will be from 0 to r minus 1. If r is 2, digit will be from 0 to r minus 1, that is 0, 1 will be there. So 0 to 9, k, that is divisor is 3 in the given question. Now based on the k value, I will write the remainder value k minus 1. K minus 1, 3 minus 1, it is 2, 0, 1, 2. So once I find the values of all these 4, R, D, K, I have to construct a table here. I have to construct a table here. See, in the first column, I'll be taking a reminder. In the second column, I'll be taking all the possible digits. In the third column, to calculate the R value, you can see in the, you can calculate the J value as R multiplied by I added with D mod K. So this value I have to find out. That is what the thing I have written. And I have to write down this transition T of Qi comma A is equal to Qj. That is what I have written. Okay. Now, first reminder, you can see the first reminder is 0. You have to process for the first reminder I is equal to 0. You have to process all the digits. For the second reminder I is equal to 1. Again, you have to process all the digits. Okay. For the third reminder 2 also, you have to process all the digits. I'm just going to process for the first reminder I is equal to 0. The digits I have written it as 0 to 9. I have written it as 0 to 9. Okay, let it be. The first digits I have written it as 0 to 9. I have written because it is a decimal number. So 0 to 9 I have to process. Now I am just going to calculate the J value. J is equal to R multiplied by I added with D mod K. find out this value and find the mod k value. Now j is equal to r value, what I got it as 10. I value means this reminder value I is equal to 0. First digit what I process is 0. Okay, so 10 multiplied by 0, 0 plus 0, 0 only. So 0 mod 3 will give you the value as 3. K value is 3. Okay, now similarly I value will remain same, digit will get varied. So digit is 1, 10 multiplied by I is 0, and digit is 1. So 10 multiplied by 0 is 0, 0 plus 1, 1. 1 mod 3 will give you the remainder value as 1. Similarly, change the digit value everywhere. I value remains same, R value also remains the same, and you will keep on varying the digits. First time digit is 0, second time digit is 1, third time it is 2, next 3, 4, 5, 6, 7, 8. Okay, so similarly you find the mod values. So I get the mod value as 0, 1, 2, 0, 1, 2, 0, 1, 2, 0. I will get the value. Okay, now this is a j value what I calculated using this relation. What is the first j value? 0. What is the I value? 0. Okay, so transition of qi comma a is equal to qj. Transition of, what is the I value I have here? 0. Transition of q naught. What is the input symbol, input digit I have processed? 0. That will be input symbol. A is input symbol 0. Okay, so transition of q naught on 0, this will be the output. Qj, qj means j value is 0. This is I value, this is the input symbol, this is a j value. Okay, so q naught on 0, it is moving to qj. So j value is 0, I have written it as q naught. Similarly, I value is 0, input symbol is 1, j value is 1. So q naught, qi means q naught, input symbol is 1, q naught on 1, it is moving to qj. What is the j value? 1. So I have written it as q1. Similarly, I value is 0, so I have written transition of q naught. The input digit is 2. Q naught on 2, it is moving to qj. J value is 2. Instead of qj, I have written it as q2. Similarly, you have to write the transitions. After calculating this j value, you have to write the transition. Now this is for the remainder I is equal to 0. This is for the remainder I is equal to 0. Now I have to proceed for I is equal to 1. Okay, now again see, digit will be from 0 to 9. For each remainder you need to process all the digits. Now initially remainder was 0, I have processed from 0 to 9. I found some transitions. Okay, now here I am starting with the second remainder I is equal to 1. For the first time digit is 0. Apply the value of r, I, d and k. See, r value is 10, I value is what? Now it is 1. Previously it was 0. Now it is 1. And the digit what I process is 0. Okay. So 10 multiplied by 1, it is 10. 10 plus 0, it is 10 only. 10 mod 3. The remainder what you get it as mod means it will give you the remainder 1. So similarly, apply the value of I is equal to 1. Input symbol as 1 and do the mod 3. You will get the j values here. Just apply I value, digit value, r value and the k value in the given equation. You will get the value as like this. Okay, now based on this again you have to write the transition. What is the I value? 1. So q1 on 0, it is moving to qj. J value is 1. Similarly, a transition of I value is 1, I have written it as q1. On processing the second input digit 1, it is moving to qj. Okay, it is moving to qj. J value is 2. Okay, so I have written it as q2. Similarly, based on the I value, input symbol and the j value, you have to write this transitions. Okay, now again I have to repeat for the second reminder. Similarly, you calculate the j value, write down the transition. Now I value is 2, I have written it as q2. Okay, on processing the respective input symbol, here it is 0, I have written it as 0. Okay, and the j value what I got for the first time is 2. So moving to qj means I have written it as q2. So similarly, based on the I value, j value and the digits, you will be writing the transition function here. Okay, now based on the transition function what I got for I is equal to 0, this is a transition what I got for I is equal to 0, and this is a transition function what I got for I is equal to 1, and this is a transition for I is equal to 2. Okay, now based on that I have constructed a transition diagram. You can see here. Okay, what are all the states you got it here when I is equal to 0, q naught, q1, q2, three states. Again q naught, q1, q2, q naught, q1, q2, everything. In the second table, again you can see you have q naught, q1, q2. Do you have any other states? No. In the third table also I got q naught, q1, q2. So in all the transition functions, I have got commonly three states, that is q naught, q1, q2, q naught, q1, q2. Okay, so see the transition table. I will tell you the table for I is equal to 2. Okay, this table I will tell you how to construct. I have just constructed three states, q naught, q1, q2. Okay, now I'm just going to tell you based on this transition function for I is equal to 2, how to give the transition function. Now q2 on 0, where the machine is moving on q2. So q2 on 0, the machine is moving to q2 only. Similarly, q2 on 1, it is moving to q naught. Q2 on 1, it is moving to q naught. Q2 on 1, it is moving to Q naught. Q2 on 1, it is moving to Q naught. So see the transition function Q2 on 2. The third transition Q2 on 2, it is moving to Q1. Okay. Q2 on 2. You can see Q2 on 2, it is moving to Q1. Similarly, Q2 on 3. Q2 on 3, it is moving to Q2. Q2 on 3, it is moving to q2 only. You can see self transition. q2 on 4. Okay, q2 on 4. Q2 on 4, where is that? See, q2 on 4, it is moving to q naught. Same thing. So you have to construct a transition diagram based on this function. See, go to the reminder table I is equal to 0. Look at this last column. Based on that q naught to q naught, you have to give a self transition. Q naught on q1, give the transition for 1. Q naught to q2, transition for 2. Q naught to q naught, give the transition for 3. So look at the last column of each reminder table. I is equal to 0. Look at this last column. Give the transition diagram. Sorry, give the transition in the transition diagram. Next, go to the I is equal to 1 reminder table. Look at the last column. Give the transitions. Okay, and go to the next reminder table. I is equal to 2. Look at the last column. You have to give the transitions. So by looking at the three reminder tables last column, I have given the transitions like this. If you look into the reminder tables last column, you can directly come and give the transitions. You no need to think anything, just apply the value of r, I, d, k properly. Get the transition for I is equal to 0, I is equal to 1, I is equal to 2, and based on that you will come to know that how many states are required. So in all the reminder tables, I have got three states are common states, q naught, q1, q2. So give the transitions between these three states based on the transition uh, table what you got for I is equal to 0, I is equal to 1, I is equal to 2. Now this is a complete transition diagram. See, for this also you need to write the definition. See, DFA is a 5 parameter machine. Okay, first parameter is set of states, that is q. So what are all the states I have? Q naught, q1, q2. These three states I have to group under the set of states. What are all the input symbols I have? 0 to 9 is the input symbols. And what are all the transitions you have? Already you have a transition function in the reminder table, so no need to write it once again. And you need to write what is the start state and what is the final state. Always the start state will be your q naught. I have made this q naught as a final state also. Why I have made means, see, in the given question, divisible by k means divisible by 3. When you can say number is divisible by 3, when you can say a number is divisible by 3, when you get the remainder as 0, when you get the remainder as 0, when you divide the number by one more number, if you get the remainder as 0, it means that that particular number is divisible by the given number. Okay, if I say 9 is a number, 9 is divisible by 3, because when I divide 9 by 3, I get the remainder as 0. So divisible by 3 means a remainder should be 0, then only I can say it is divisible by 3. If since the reminder is 0, I have made the q naught state as the final state. Q naught state as final state. Suppose the number divisible by 3 should not be equal to 0. If I say, listen to the statement, if I say the number divisible by 3 should not be equal to 0 means q naught will not be the final state other than 0. The remaining states will become the final state. Since I have a divisible by 3, remainder is 0. So I have made q naught as a final state. If the remainder should not be equal to 0 means q naught will not be the final state, q1 will be the final state, q2 will be the final state. That is a logic to find out what is the final state. Okay. If it is divisible means obviously 0 is a remainder, so make a q naught as a final state. If if it is not divisible by 3 means remainder will not be 0. So other than q naught you have to make other states as final states. See, a second type of problem is over. Now this is the third type of problem, string length mod k problem. String length mod k problem. This also can be solved using a relation T of Qi on A. T transition of Qi on A. Machine moves to the state q of I plus 1 mod k. This I plus 1 mod k in the subscript. Okay, not in the equal script. It is in the subscript. So using this relation, you can easily solve this problem. Okay. So directly we'll get into the problem. DFA to accept the language L is equal to W, where W is length of the W. If any string, if it is placed within the pipe symbol, pair of pipe symbols, if any string which is placed within the pair of pipe symbol means, it means that it is a length of the string. Okay. So W, I have written it here. It is just a string. If I include this W within the pipe symbol, it means that length of the string, okay, length of the string mod 3 should be equal to 0. Okay, where summation is equal to a comma b. That means the string can have a combination of a's and b's. String can have a combination of a's and b's, but make sure the length of the string should be divisible by 3, because mod 3 is equal to 0 given in the question. Since in the question itself length, string length mod 3 is equal to 0 they have given, right? So since they have given the value should be 0, or this 0 will be the point to identify which is the final state. Mod 3 value should be equal to 0 they have given. So that means 0 is the final reminder. So I'll be considering q naught. I'll be considering q naught as a final state. If they say string length mod 3 should be equal to 1, if they give, q1 will be the final state. If they give this should be equal to 2 means q2 will be the final state. So based on the value what you have here, okay, you have to decide. If they don't give any 0, 1, 2, 3, nothing they have given means, if they have given string length mod 3 alone, assume they have given string length mod 3 alone, they have given, they have not specified whether it should be equal to 0 or it should be equal to 1 or it should be equal to 2, nothing they have specified means, by default you have to consider the value as 0. If they give the value, use a specific value. If they don't give the value, by default you consider the value is 0. So make q naught as a final state. Now here also I have to find out string length mod k. I have to find out what is a k value. See, string length is this. Okay, mod w. This is a string length mod k. Okay, so this is the k value. This is a string length and this is a k value. Okay, now to make use of this relation, I need to know the k value. I need to know the I value. K is the divisor. I is a reminder. As I told you for the previous example, k is a divisor. I is a reminder. Okay, now k is 3 in the given question. So I value, that is a reminder value, varies from 0 to k minus 1. K is 3, 3 minus 1, it will be 2. So reminder varies from 0 to 2. Okay, now question is see, I have to construct a table. I have to construct a table here. In the first column, I'll make use of the reminders. Okay, in the first column, I'll make use of the reminder. In the second column, I'll make use of this input relation. I will make use of this relation, given relation. I have written it here. இது எடுப்பாடு முடியாதா? Okay, see here. See, I have just going to construct a table. In the first column, take the reminder values. In the second column, make use of this relation. Okay, now a is nothing but it is a input symbol what we are going to use. In the given question, the input symbol summation is given with a comma b. So this a is getting replaced with both the input symbol a comma b. Okay, this input symbol a is replaced with a comma b, because in the given question they have given input symbol is a comma b. So I is 0 1 2. In the relation t of qi, I have written, that is t indicates transition, qi comma a is the input symbol given in the question. In the given question, summation means input symbol. The input symbol is a and b. I have written it within the pair of curly braces. Now qi plus 1 mod 3. Qi plus 1 mod 3. I plus 1 mod k value is 3. I have written it as 3. Now apply the value of I. I is equal to 0. Now t of qi means I value is 0. I have written it as q naught. Input symbol, write it as it is, because q naught on a as well as q naught on b you are going to process. So write the input symbol as it is, and q naught on a comma b I'm just going to find out using this relation. Q of I value is 0. 0 plus 1, it is 1. 1 mod 3 is, okay, 1 mod 3 is 1 only. Okay, so q is there. Okay, so q is there, this value is 1. So q followed by 1. So machine from q naught on processing the input symbol a as well as b, it will move to the state q1. It will move to the state q1. Okay, so next time I value is 1. Now transition of q1. Okay, qi means I value is 1, q1 on a comma b. I'll apply this right side relation. I plus 1, I value is 1, 1 plus 1 it is 2. 2 mod 3 will give the value as 2 only. So q followed by 2, q2. So transition of q1 on a comma b, machine will move to q2. And next I value is 2. Qi means q2. Q2 on a comma b is equal to q of I value is 2. 2 plus 1, it is 3. 3 mod 3 will give you the reminder 0. So I have written it as q naught. So just apply the value of I and k in the given relation. You'll get the transition function. Now, as I told you, in the given question, they have given mod 3 is equal to 0. 0 is a reminder. So I have made q naught as a final state. So if you see the table, only three states I get: q naught, q1, q2. I have made use of q naught, q1, q2 I have used. You can see I have made use of q naught, q1, q2. Okay. Now start from q naught on a comma b. Okay, where the machine is moving on, you can see q naught on a comma b. Machine is moving to q1. Q naught on a comma b, it is moving to q1. Similarly, q1 on a comma b, it is moving to q2. q1 q1 on a comma b, it is moving to q2. Similarly, q2 on a comma b in the table, it is moving to q naught. Okay, so it is moving to q naught. So based on this table, easily you can construct a transition diagram. Okay. Now for this also you have to write a definition. Don't forget to write the definition. because I have not written it in the PPT. You have to write it. Please don't forget to write the definition for each transition diagram, what you construct for DFA, NFA, whatever it is. So the next type of problem is we have seen string length mod k. Okay. Now along with this, we are going to make use of relational operator. String length mod k problem just now we have seen. Along with the relational operator, what we are going to see. Okay. Now question is DFA to accept the language. Okay, L is equal to W such that length of string length mod k greater than or equal to, you can see, okay, you can see the relational operator what I use it is greater than or equal to, and that is followed by again string length mod k problem. See, left hand side you will have one string length mod k problem, right hand side also you will have one string length mod k problem. In between these two string length mod k problem, you will make use of the greater than or equal to symbol. Okay, now see, construction of the left hand side string length mod k problem as well as the right hand side string length mod k problem is similar to the previous problem. This relational operator, we will use it to decide which should be considered as a final state. Only for that we will be using this relational operator. Okay, we'll see. We'll try constructing this. I have given you one more relational operator also. I'll tell you how to do this. Then we'll see. If time permits, we'll see this also. Okay. Now I'm just going to construct a transition diagram for the left hand side string length mod k problem as well as the right hand side string length mod k problem. Then I'll make use of this. Now what is the left hand side? String length mod 3 is the left hand side problem, and string length mod 2 is the right hand side problem. I've just taken. Okay, you have to use the same relation. String length mod k problem, what is the relation you have used? This is the relation. Same relation you have to use for with relational operator also. See, I have taken the left side string length mod k problem. What is the left side? String length mod 3. Okay, so I have taken string length mod 3. I have taken where input symbols are a comma b. This is just now we have constructed. You can see this is a problem, same problem, right? String length mod 3 equal to 0 is a problem what we have constructed. So I will not solve it once again. Just I am going to copy the transition diagram from here to that problem. Okay, same thing whatever I have explained you now, using the same reminder I equal to 0 1 2 3, using the relation t of qi comma a equal to qi plus 1 mod k. Same thing I have copied here. Now for the left hand side problem I have done it already, so just I have copied. Okay, now left hand side, right hand side I have a string length mod 2 is equal to 0. Okay, string length mod 2 is equal to 0. Now in this, k value is 2, I value means k minus 1, it is 1, so 0 to 1. Always the reminder value varies from 0 to k minus 1. K value is 2, so it will go up to 0 to k minus 1 means 0 to 2 minus 1, it is 0 and 1. So apply in the table. I is equal to 0. T of qi means q naught on a comma b is equal to q of 0 plus 1. I value is 0, 0 plus 1, 1. 1 mod 2. Here I have to change it. It is not 3. Okay, it is 2. Because in the given question it is 2. Please change it as 2 here. 1 mod 2 is equal to 1 mod 2, the value is 1 only, so I will get the final status, that is a transition status q1. So q naught on a comma b, machine will move to q1. Q naught on a comma b, machine is moving to q1. Similarly, apply the value of I is equal to 1, you will get t of q1 on a comma b is equal to q of 1 plus 1 mod 2 is equal to q of 2 mod 2. 2 mod 2 means the value will be 0, so q naught. So I need q naught and q1 two states. So I have written it as 0 and 1. You can write it as q naught and q1 also. It is your wish. Q naught on a comma b moving to q1. q1 on a comma b moving to q naught. So this is the transition diagram for the right hand side string length mod k problem. So for the left hand side, this is the transition diagram and table. For the right hand side, this is a thing. So separately I have constructed two different transition diagrams for left side as well as the right side. Now I am going to apply that relational operator in between these two transition diagrams. For that I have to make use of this table. For that I have to make use of this table. Okay, see, first find out the states of first transition diagram. What all the states I have in this? This is the first transition diagram. What all the states I have in this? I have a q0, q1, q2. I have written it as 0 1 2. Okay, I have written it as 0 1 2. The first transition diagram, I have a three states, 0 1 2. Okay, and the second transition diagram, I have two states, 0 and 1. That is what I have written. States of first DFA is 0 1 2. Let us consider it as a q1. States of second DFA is 0 and 1. Let us group it under the name q2. Now find the cross product of q1 and q2. Find the cross product of q1 and q2. Cross product is nothing but 0 concatenated with 0 and 1. 1 concatenated with 0 and 1. 2 concatenated with 0 and 1. Now 0 comma 0. 0 comma 1, that I have written it. Now 1 comma 0, 1 comma 1. Okay. Now 2 comma 0, 2 comma 1, that I have written it. Okay. So by doing a cross product between q1 and q2, I have written this. Okay. Now let us construct a table. Now let us construct a table here. Okay, so the first column indicates the transition of final DFA after applying the relational operator greater than or equal to. Okay, this is a final transition. Okay, now the transition of first DFA, transition of the second DFA, and the transition to which state the transition is going on, that is a final column. Okay, now P comma Q is nothing but the first state. What is the first state I have? 0 comma 0. That is called as P comma Q. On A, you have to split and write. P on A will give you the first DFA transition. Q on A will give you the second DFA transition. Okay. So now in the cross product, what is the first state? 0 comma 0. So transition of 0 comma 0 means this is P and this is Q. Okay. On A comma B, because input symbol is A comma B, which is given in the question. So I have replaced with A comma B. Okay. Now you have to split and write. 0 on A, write it under the second column. 0 on B, write it in the third column. Okay. If you want to find the transition of 0 comma 0 on A comma B, you have to split the transition and write 0 on A, write it. 0 on B, write it in the third column. Now I have written transition 1 of, why I have written it as transition 1 means this is a transition from the first DFA, this is a transition from the second DFA. Okay. Now 0 on A comma B, go to the first DFA. Okay, go to the first DFA. I'll just go to the first DFA. Go to the first DFA. This is the first DFA. 0 on A comma B. 0 on A comma B. Where it is moving on? It is moving on to 1. Okay, it is moving on to 1. So 0 on A comma B. 0 on A, sorry, don't write it as 0 on A, 0 on B. Write it as 0 on A comma B in the second column, 0 on A comma B in the third column. Now in the first transition, 0 on A comma B, machine was moving to Q1. So I have written it as 1 here. So go to the second transition diagram, 0 on A comma B. You can see 0 on A comma B, it is moving on to the state Q1. So I have written it as 1. Now when you write the final transition in the fourth column, combine these two values, the output of the first transition and the output of the second transition. What is the output of the first transition? 1. Output of the second transition is 1. So 1 comma 1 I have written. Now I started with the initial state 0 comma 0. So second time when I want to start, I have to start with the state what I have got it as a output in the previous step. So what is the output I got it in the previous step? 1 comma 1. So start your process from the previous output 1 comma 1. So transition of 1 comma 1 on A comma B. Again 1 on A comma B, write in the second column. 1 on A comma B, write it in the third column. Go to the first DFA, find out 1 on A comma B, where the machine is moving on. It will get moved on to the second state. See, go to the first transition diagram. 1 on A comma B, it will move to the second state. Now go to the second transition diagram, find out 1 on A comma B, where does the machine moves. It goes to the 0. Now combine the output of the transition 1 and transition 2. It is 2 comma 0. I have written it. Now this is the output what I got. I have to start my process from this previous output 2 comma 0. Again 2 comma 0 on A comma B. I have to write it 2 on A comma B. Find out machine is moving to the state 0. This should be written from the first transition diagram, and this should be written from the second transition diagram. Now 0 on A comma V, the machine is moving to the state 1. So combine this 0 comma 1. Start your process from 0 comma 1. Again 0 comma 1 on A comma B, written right. 0 on A comma B, it will go to the state 1. 1 on A comma B, go to the state 0. Combine these two outputs 1 comma 0. Start your process from 1 comma 0, 1 comma 0, A comma B. 1 on A comma B, I will get the transition status 2 from the first transition diagram. 0 on A comma B, I will get the transition from the second transition diagram as 1. Combine 2 comma 1. So start your process from 2 comma 1. Start your process from 2 comma 1. 2 on A comma B. From the first transition, it is moving to 0. 2 comma, sorry, 1 on A comma B. It find the transition from the second transition diagram. It will move on to the state 0. Combine 0 comma 0. See, you started your process.
How to came, ma'am?
How to?
How to came?
How to came? Where?
People are asking.
Somebody has asked how 2s come. May I know your doubt, please?
Type it clearly.
Type it clearly. I didn't understand your doubt. Type it clearly. How does 2 came? You have asked. Somebody has asked. So please mention your doubt properly.
Okay, start.
See, in this location you can see, okay, see, this is the previous output. I started from 1 comma 0, 1 comma 0 on A comma B. I have to find out. Now I will split and write 1 on A comma B, 1 on A comma B. I need to find out. So go to the first transition diagram. Go to the first transition diagram. See, 1 on A comma B, where the machine is moving on. It is moving on to the state 2, right? 1 on A comma B, it is moving on to the state 2. Okay, that is why I have written it as 2 over there. So when you write the first transition, look at the first transition diagram. When you write the second transition, look at the second transition diagram. Okay, so 1 comma 0 on A comma B, I got the value as 2 from the first transition diagram. Now 0 on A comma B, I have to look into the second transition diagram. If I look into the second transition diagram, 0 on A comma B, it will move on to the state 1. So I have written it as 1. So combine these two output. Output of first transition is 2. Output of second transition is 1. So combined the transition as 2 comma 1. So from 2 comma 1, I have to proceed. So I have started in the last row. Please everyone look into the last row. 2 comma 1 I started. 2 comma 1 on A comma B. 2 on A comma B. If you look into the first transition diagram, machine will move to the 0. Okay. 1 on A comma B, if you look into the second transition diagram, machine will move to 0. So 0 comma 0 is the output what I got. I started my process from 0 comma 0. When you get 0 comma 0 in your transition once again for the second time, you have to stop your process. See, nowhere I got 0 comma 0. When you start and end with 0 comma 0, you have to stop your process. Okay, now this is the states. 0 comma 0 is a state, 1 comma 1 is a state, 2 comma 0, 0 comma 1. So the cross product of the states from DFA1 and DFA2, these are the states of your final DFA, and these are all the transitions. Okay, let us see. Oh, see, 0 comma 1, 1 comma 1, 2 comma 2. I have to write the states in order. What is the first state I have processed? 0 comma 0. 1 comma 1 is the second state, 2 comma 0 is the third state, 0 comma 1 is the fourth state, and 1 comma 0, 2 comma 1. These are all the states order what you, how you need to write it. In the similar way I have written. Okay, 0 comma 0, 1 comma 1, 2 comma 0, 0 comma 1, 1 comma 0, 2 comma 1. This is the order what I have written. Okay, now I'll tell you how I have made. Some states are double circle, some states are single circle. I'll tell you. Now I have written all the states totally. In the previous diagram I have 1 2 3 4 5 6 states. 6 states I have written in the same order from left to right I have written. Okay, now 0 comma 0 on A comma B, 0 comma 0 on A comma B. Look at the first column and the last column. 0 comma 0 on A comma B, where the machine is moving on, it is moving on to the state 1 comma 1. See, I have given 0 comma 0 on A comma B, it is moving to 1 comma 1. Similarly, 1 comma 1 on A comma B, it is moving on to 2 comma 0, 2 comma 0. 2 comma 0 on A comma B, 2 comma 0 on A comma B, the machine is moving to 0 comma 1. So 0 comma 1. Similarly, okay, 0 comma 1 on A comma B, the machine is moving to 1 comma 0, 1 comma 0. 1 comma 0 on A comma B, it is moving on to 2 comma 1. You can see 1 comma 0 on A and B, it is moving to the state 2 comma 1. Okay, and 2 comma 1 on input A and B, it is moving to 0 comma 0. You can see 1 comma 0 on A comma B, 2 comma 1, 2 comma 1 on A comma B, it is moving to 0 comma 0. I have connected. Okay, now based on the left hand side string length mod k problem, right hand side string length mod k problem, I have constructed this. Now the relational operator which is given in the question is greater than or equal to. The relational operator what they have given in the question is greater than or equal to. This relational operator I will make use just to decide which will be the final state. Now the first value is 0, that is this is DFA1. Apply the first value is value of the first DFA. Second value is value of the second DFA. Apply the relational operator between these two values. 0 greater than or equal to 0. Condition is true. Yes, 0 is equal to 0. So if the condition is true in between these two values, I will make this as a final state. 0 greater than or equal to 0. Condition is true. So final state. 1 greater than or equal to 1, apply the relational operator greater than or equal to 1 between these two values. 1 greater than or equal to 1, condition true, make it as a final state. 2 greater than or equal to 0, condition is true, final state. Now if you look into this, 0 greater than or equal to 1, no, condition is not true. 0 is less than or equal to 1, not greater than or equal to 1. So condition is not true based on the relational operator. So this remains as a non-final state. This will not be a final state. Now similarly 1 comma 0 is 1 greater than or equal to 0. Condition is true, final state. 2 comma 1, 2 greater than or equal to 1, condition is true. So this is a final state. So after constructing a final DFA, apply the given relational operator. Okay, apply the given relational operator.
I will take one.
I will apply the relational operator between the two state numbers in the transition diagram. If that condition is true for those two transition values, then I will make it as a final state. Otherwise, I will make it as a non-final state. If I say instead of relational operator greater than or equal to, if I say the relational operator is not equal to, which are all the states will become the final states. Now, in this case, relational operator is greater than or equal to. If I say relational operator is not equal to means 0 is equal to 0. This will not be a final state. 1 is equal to 1, not final state. 2 is not equal to 0. This alone will become the final state. 0 is not equal to 1. This will also become the final state. 1 is not equal to 0, final state. 2 is not equal to final state. And these two are equal, so those two will not be a final state. So based on the relational operator, you have to decide which state should be considered as a final state. For that alone, we'll be using a relational operator in between those two problems. Clear with this? See, the last type of problem what we have is a number of specified symbols mod k problem. Okay, in the previous case, the entire string length we have taken. But here we are going to take a length of a specified symbol. That is a difference. Okay, the previous type of problem, if the string is AABB, okay, string length is 4. If the string is AABB, string length is 4. The entire string length I will take, I will do the mod. Okay, but in the last type of problem at present, what we are going to see is, you will, if you have a string as AABB, string length of A mod K. Okay, string length of A mod K I will take, or string length of B mod K. If I say string length of A mod K means in AABB, the number of A's present is 2. That length alone I will take and I will find the mod. If I say B means the length of B alone I will take and I will do the mod. Same problem. Okay. See, DFA to accept the language, the number of A present in the W, that is string, mod 5 should not be equal to 0. See, if it is equal to 0 means 0 will be the final state. If it is not equal to 0 means other than 0, every other state will become the final state. Okay. The relation is same. Whatever relation we have used for string length mod k, same relation we are going to use for number of specified symbols mod k. Concept is same. In the previous string length mod k, entire string length we'll take and we'll do the mod operation. Here, the symbol, whatever they specified in the question, only the length of that particular symbol we'll take and we'll do the mod operation. That is the difference. Same table you have to do. See, here in the given question, k value is 5. Okay, k value is 5. You have to find out the I value. I is equal to remainder. Remainder means 0 to k minus 1. 0 to 5 minus 1 means 4. So 0, 1, 2, 3, 4. So 0, 1, 2, 3, 4. It will be the, one second. ఏంటి? See, I have taken from the given question, k value is 5. The same relation, transition of qi comma a is equal to q of I plus 1 mod k. In the given question, the k value is 5. Okay. So I have just taken the remainder as 0 to 5 minus 1, 0 to 4 I have taken. Apply the I value. The input symbol what they have given in the question is a alone. Okay. Number of a is mod k. Okay. That is length of a mod 5 should not be equal to 0. That is the question. So apply the value of 0, q 0 on a. I value is 0, 0 plus 1, 1, 1 mod 5 will give you 1 only. Similarly, apply the I value as 1. Transition of q1 on a is equal to q of 1 plus 1 mod 5. 2 mod 5 it will be q2. So next time I value will be 2. Transition of q2 on a, q of 2 plus 1, I plus 1 means 2 plus 1 mod 5, it will be 3 mod 5, the result will be q3 only. Similarly, apply the other values of I, you will get the value as q1, q2, q3, q4, q0. Now what are all the possible states I have? q0 to q4. Okay, q0 to q4 I have taken, q0 to q4 I have taken. Now q0 on A, where the machine is moving on, q0 on A, where the machine is moving on, q1. Q1 on A, the machine is moving to q2. Q2 on A, the machine is moving to q3. Q3 on A, q4. Q4 on A, q0. Similarly, I have q0 on A, q1. Q1 on A, q2. Q2 on K, q3. Q3 on A, q4. Q4 on A, q0. So this is a transition diagram what I have constructed based on this transition table. Okay, how to find out which is the final state means, as I told you, it is specified it should not be equal to 0 means q naught should not be the final state. Other than q naught, every other state will become the final state. Should not be equal to 0 means this is a non-final state, and q1, q2, q3, q4 are the final state I have just specified. Okay, the next is number of specified symbols mod k problem with a logical operator. See, left hand side you will have the number of specified symbols mod k problem. Left hand side, right hand side also you will have the number of specified symbols mod k problem. In between you will have some logical operator, and you will have or operator you will have. So and or, these two operators what we use it here as a logical operator. See, this is a question. Number of specified symbols mod 2 is equal to 0. Number of specified b mod 2 is equal to 1. So two different number of specified symbols mod k problem they have given. In between they have used a and operator. The relation you need to construct a transition diagram using the same relation. For this you have to use for this also. Now let us take the transition table and the diagram for both the problems. This is the left hand side problem. Number of a's mod 2 is equal to 0. This is a table what I get. K value is 2. I value is k minus 1 means 0 and 1. Apply the I value in the same relation. Q naught on A, it moves to Q1. Q1 on A, it moves to Q naught. Now on the right hand side, you have this as a problem. Okay. Number of B's mod 2 should be equal to 1. They have given. 1 second. Should be equal to 1. So 1 will be the final state. So 1 will be the final state. Mod 2 is equal to 0. You construct. Now you see I value is 0 and 1. Apply in the equation. Q naught on B, it will go to Q1. Q1 on B, it will go to Q naught. In this case, Q naught will be the final state. Now in this state, in this transition diagram, Q1 will be the final state. Here you change it, change the value as 1. Here in this case, change the value as 1. Here the value is 0 only. In the left hand side problem, final state will be the Q naught. In the right hand side problem, final state will be the Q1. Okay, now again do the same cross product. See, I have the states are 0 and 1. Here also 0 and 1. If I do the cross product, I have taken the states of first DFA as A naught A1, second DFA as B naught B1. Instead of taking Q naught Q1, Q naught Q1 two times, the states of first DFA is A naught A1 I have taken. States of second DFA is B naught B1 I have taken. So do the cross product. A naught B naught A1, sorry, A naught B naught, A naught B1, A1 B naught, A1 B1. So these are all the cross product states. Okay, now these are all the states of the final DFA. I have taken A naught B naught, A naught B1, A1 B naught, A1 B1. I have taken in the order only. Same order. Same order I have taken 4 states. I have taken it as 4 states. Here, if you want to, when you have a logical operator in the given question, you need to have a one predefined concept in your mind that you have to give the bidirectional vertical transition for the first input symbol, bidirectional horizontal transitions for the second input symbol. After doing the cross product of the states of first DFA and second DFA, that will be the final states of the final DFA. You can see these are all the states after doing a cross product. And how you need to connect means, when you have a logical operator and or the or logical operator, give the vertical bidirectional transition for the first input symbol. What is the first input symbol? A. So I have given vertical, that is vertically I have to give the bidirectional transition for the input symbol. So this is a vertical bidirectional transition for the input symbol A. Here also I have given. Give the horizontal bidirectional transition for the second input symbol B. Directly you can give. Okay. When you have a AND operator or operator, give vertical bidirectional transition for A, horizontal bidirectional transition for B. Now, how to decide which is a final state means, in the given question, left hand side, what is the reminder value they have given? 0. Okay. And in the right hand side, the reminder value what they have given it as 1. Okay. If they give 2 and 1, okay, sorry, 0 and 1 is a reminder what they have given in the question. So in the transition diagram, this will become the final state. This will become the final state. If they give first reminder is 0, second reminder is also 0, means A naught, B naught will become the final state. Suppose if the first reminder is 1, second reminder is 0, this will become the final state. If both the reminders are 1 and 1, then A1, B1 will become the final state. Okay. Based on the reminders, you decide which should be considered as the final state. Okay. Okay. Thank you for cooperating and listening to the introduction of the first module. Up to DFA, I have finished taking the construction of different transition diagrams. Now I hand over to my colleague, Professor Jivita ma'am. She'll be continuing with the non-deterministic finite automata. Thank you. If you have any queries, you can post your queries in the chat box. So I will answer to your queries. Thank you all.
Good afternoon, everyone. This is Jeevita from AMC Engineering College, working as an assistant professor in CSE department. Yeah, able to hear me? Please ping me in WhatsApp if you have any doubts. Let's make it interactive session. And I'm going to start from the topic. One second, I'll share my PPT. Able to see the PPT? In Q&A, some questions are there. Okay. Can anyone say that whether it is able to hear me? Is my voice is clear? See in chat box. Chat box, correct. Yes, no? Okay. So we'll start with the topic NFA, non-deterministic finite automata. Okay. So far we saw that deterministic finite automata. So what is the difference between the non-deterministic and deterministic? Okay. So the in deterministic finite automata, you can see that there won't be any transition for the same input from one state to another state. Okay. You cannot able to give like that. If you give for the same transition, for the same input, if you give many transitions, then it won't be a DFA. Okay. So that feature is possible in your NFA. Okay, so you can able to give many number of transition for the same input. Say for example, A is the input. For A, you can able to give the transition from the state to Q naught. It can able to reach to Q1 or Q2, or it can able to go to Q3 also. Okay, for the same input. Okay, that is called as non-deterministic finite automata. Okay, so you can see that the transition function for the DFA. What is the transition function for DFA from one state? If you are if you are having a transition for in DFA from one state to another state, there will be some input. So a state will be considered as Q. Okay, so we know that it has some five tuples. What are all the five tuples? Q summation is nothing but your input alphabets. Then this delta symbol represent the transition, and S is the start state. A is the is your final state. Okay, is a set of final states we can able to have. Okay, so it is all everything is same. Okay, your NFA and DFA is everything, the tuples, everything, all the definitions, everything is same. What is the only difference? You can able to have more number of transitions for the same input. That is the difference. So the transition function in DFA, we will be having Q cross summation, which leads to another state, which can be one single state. Okay, which can be one single state. But in NFA, it can be many other states. Yes, as I said, it may go to Q1, or it may go to Q naught, or Q3, or QF. Whatever the state, how many states present in the DFA, it can possible to travel to any other transition. So we can represent that transition function as Q cross the input alphabets, which gives the output will be, it leads to any many number of transition. So 2 to the power of q we can able to say. Okay, and rest all everything we will be having the same set of definitions. Okay, so this is the difference between the NFA and the DFA. We'll go to the next. Okay. So NFA to accept NFA to accept the language, given language A B A B power n, or A B A power n, where n is greater than or equal to 0. So construction of NFA is easy, and it won't be very difficult as compared to your DFA, because whatever it is given, we need to construct. So we need not to think much in the NFA concept. Okay, here you can see that the ABA, here ABA is your mandatory case, which is given in the red color. Okay, so which is like a mandatory. It is a, in the input, this should be like a must and should, it should come in your DFA. Okay, then only the NFA or the machine will accept the input. Such a kind of string only it will accept. If it is starting with B, it will not accept. Okay, because A, B, A followed by B power n. B can be many. B power n means n is greater than or equal to 0. N is specified as greater than or equal to 0. It can be null also, it can be many in number also. But starting should be A, B, A. So you have to, as like the DFA, we have to design for the mandatory case first. So design for the mandatory case A. So for A, how many number of input is must here? A, B, A. There are three inputs. If there are three inputs, how many number of states you should have? You should have more than one, at least. This is the rule of the construction, right? So if you have two inputs, you will be definitely having three states. If you have three inputs, you will be having four states. So like that, it will go. So here these three are the mandatory. So we are having four number of states. We are having four number of states, which is Q naught, Q1, Q2, and Q3. Okay, and design the mandatory case A. For A, I am taking two states, Q naught to Q1. It is going Q naught to Q1, and from Q1 to Q2, it is going for B transition we have taken. For Q2 to Q3, A transition we have taken. Followed by, here it is B power n. So b power n, it can be 0 also, it can be greater than 0 also. What is the condition given for n? N can be greater than or equal to 0. So b can be null or it can be many in number. So to show that, we will be always using the self loop. Okay. So self loop concept, when we'll be using, if it is 0 or more in number, if it is repeatedly, if it is coming, then we'll be using the self loop concept. So where it is coming b power n, it should come at the end of the string. So at the end of the string, the last end of the string, which will be q3. So q3, in q3 we are giving the loop. Okay. Then similarly, here this is one kind of input, or in the question they have given another kind of input, which is ABA power n. So here ABA, here AB is a mandatory case. So first two digit or mandatory, two characters are mandatory, then followed by A power n. This n can be null also, or it can be many in number also. So we have to design for the mandatory case first. So if, as I said, there are two mandatory strings, so you should design with three number of states. So we have to take Q0, Q1 and Q2. Okay, three number of states we have taken. So in first, that A B transition I have showed from Q0 to Q1, and B transition we have showed from Q1 to Q2. Last state will be the final state. Okay, and followed by, at the end of that, many number of A can come. So give a self loop. If it is many number of A, it will accept, otherwise it will not accept it. Okay, otherwise it will not take it. It will end from ending with, it will end with only A B also. Okay, so these two we have designed. So now here what is the given? Either this or this it will take. Okay, either this or that, any kind of input, if it is comes also, it will take. So we have to design, we have to combine these two transition diagram and make it as a single diagram, because any kind of input, if it comes in this first pattern or in second pattern, it should accept both. Okay, so we have to design NFA. So why it is called as NFA? As I said, from Q0, we have the transition for A to Q1 also and to Q4 also. Okay, so this if the transition, if the string, if you are giving with ABA, it will go in this direction and it will accept, go to the final state and it will accept the strings. Okay, if it is comes in the if it is comes in the AB followed by A power followed by AAA. Okay, suppose you are giving the input, once again. So for this case, suppose you are giving the input A, B, A and followed by B, 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 B. If you are giving the input, then it will take the first root. This way it will accept. Okay. So if you are giving the input A, B, A. Okay. If such case, it will accept the input from the uh, Q5. Okay, so this is by combining the problem, we have made the DFA, we have made the finite state. So why it is called as NFA? Since we have, since the state from Q0, there are two A transition for the same input. Here also it is A, here also it is A, and here also it is A. So for the same transition, we are showing the input. So it is called as NFA. Okay. So next topic we need to see is NFA to DFA conversions. Okay, so we need to convert the NFA to DFA. If sometimes they will be asking that to give a they will be giving a table, NFA table or NFA transition diagram, which will be asked as an important question also, one of the important question also. So that will be you have to convert into NFA to DFA. Okay, so here NFA means you will be having for the same input many transitions. So that should be reduced. All the transitions for the repeated transition should be reduced, and that and then you need to convert into a DFA. Okay. So what are all the steps to convert the NFA to DFA? Is identify first, you need to identify the start state of the DFA. Whatever the start state given in the DFA, either they will give the table or the diagram. Okay. So if they give the table, you need to construct, you need to draw a diagram, or directly sometimes they will give the diagram itself. Okay. So here we will show that how you can able to, you already know that how you can able to, if the table is given, you need to convert into a diagram, or diagram is given, you need to convert into a table. So that is all you might have practiced in DFE. Okay. Then what is, whatever the start state of the DFA will be the start state of your NFA also. Identify the start state. Then identify the input alphabet. So if the input alphabet, if the input alphabet given in the question is A comma B, then the same A comma B will be the your NFA input also. Okay. If it is 0 comma 1, then it is the same input will be given for your NFA also. Okay. And the third step, this is the important step. It is like a formula. You can able to memorize this. So identify the transitions of the DFA. So what we are going to find is DFA. Okay. So how we are going to find, the given is NFA. So from the NFA, you are going to identify the transitions for all the inputs, then combine the state and form a new state. Okay. So here you can see that the we are going to find the DFA, that is going to be represented as delta D. Okay. Since it is DFA, delta D we have to represent. Delta D for all the states, for all the input you are going to find. Okay. Then only we can able to construct a proper DFA, right? For how many states are there, that many number of times you need to convert, how many for the all the state and all the inputs you need to find out. So how it can be elaborated, transition, which is nothing but a delta n. So the given from the given diagram, you need to find for the input state, some input state, some state. From that, what is the input A, what is the transition. Okay. You need to take that. So from other state, so say for example, there are three states, Q0, Q1, and Q2. So from Q0 input transition for A, what is that? You need to find out. Then from Q1 input transition A, what is that? You need to find out. Then similarly from transition 3, all these things you have to find out. Then make a union operation. You will be getting one new state. Okay. So those states will become your the states of the DFA. Okay. So this will be the repeated step, and you need to find for all the inputs and for all the states. Okay. So identify the final state. How we can identify the final state? So as like the start state, as like the input which is given in the NFA will be the states, will be the alphabets for the DFA also. Similarly, here whatever given in the final state of the NFA will be the final state of the DFA also. Okay. So if suppose Q2 is the final state in the given question. Okay. So wherever here in third step, we might have found that many number of new states. Okay. Suppose Q2 is coming in first state of DFA also, then you make that as a final state. If it is coming in the second state, then you make second also a final state. If it is coming in third step, then also third step will be the final state. So wherever Q2 we are finding, so those state will become the final state of the DFA. Okay. So these are all the steps. Convert the NFA to its equivalent DFA. So first we'll take one NFA diagram. So why it is called as NFA? Since we have the two input, which means the input symbol A, it is having the transition from the same state Q0. From Q0, it is having the transition to Q0. From Q0, it is having the transition to Q1 also. From the same state Q0, there is it is appearing two times, right? The input is appearing two times. So it is called as NFA. Okay. So this transition diagram we are going to convert into a DFA. Okay. So how to convert that? First you need to it's better to create a transition table, NFA table, so it will be easy for you to construct. Okay, so if they given a diagram, you better construct a table. If directly table is given, then it is well and good, you can able to continue directly. Okay, so transition delta of NFA will be represented as delta capital N. Okay, since it is NFA, delta capital N. So what are all the inputs? A and B are the inputs, A and B. And what are all the states? That will be represented as a rows. Column will be representing inputs and this rows will be representing your states. This we already know, right? So Q naught on the input of A, it goes to Q naught and Q1. That's why we have written Q naught comma Q1. Okay. Q naught on the input of B, it goes to Q2. So we have written it as Q2. Okay. Then Q1 on the input of A, there is no transition. So it is represented as null. Okay. This no transition of null can also be represented as null set also. Okay. Like this also sometimes in the question paper they will represent um, empty set. So that also considered as a clear, how to clear. Okay, so null will be represented like that also. Then after constructing this for all the states, we need to start constructing a converting from NFA to DFA. So whatever the start state of the DFA will be the start state of NFA also. So what is the start state? Q naught is the start state. So Q naught is the start state for NFA also. Sorry, DFA also. Input alphabets A comma B is given. So A comma B will be the DFA input alphabet also. Okay. Then the transitions. So you need to find the third step. The third step is the formula. What is that? You need to find the transition for D, which is represented as DFA. We are going to find the transition of DFA. So it is represented as delta D. Okay. So how we are going to find? Initially, I'm going to process with my start state. Okay. So start state is Q naught. Q naught on the input of A also I need to find, and on the input of B also I need to find. So A and B I am going to find. So on the input of A first we will be finding. So transition of N. Why it is represented as N? Because we are going to utilize the table of N of A. Okay. So we are representing this as delta N. Okay. So from the given question. So Q naught on the input of A, where it is going? Q naught comma Q naught on the input of A, it goes to Q naught comma Q1. So that's why we have written Q naught comma Q1. Okay. And here Q naught on the input of B, where it is going? It goes to Q naught, only Q naught. So this is one state. So what are all the state we got here? In the first finding of input symbol A, using input symbol A, we got Q naught comma Q1. Using input symbol B, we got only Q naught. Okay. So Q naught is not a new state. Already we have processed for Q naught. So only Q naught comma Q1, this is a new state. So this new state, you need to take it as an input for the next iteration. Okay. This iteration, when you will be stopping? Whenever there is no new state in the construction, then we can able to stop the process. Okay. So until you get to the new state, we need to keep on doing this process. Okay. So this is a new state. So for the next transition, I am taking the new state. So Q naught comma Q1 on the input of A and on the input of B. So on the input of A, where it is going Q naught, it goes to Q naught comma Q1. Q1 on the input of A, there is no transition there. Okay, no transition in the diagram. Q1 on the input of A, there is no transition. It is null. So union with null, which gives you the same input, same data, right? So this union null you will be having. If you expand and write, you will be writing like that. This union and null, which gives the Q naught comma Q1. So we have taken the no, there is no, the output of this function will become q naught comma q1. Then q naught comma q1 on the input of b. Okay, so q naught comma q1 on the input of b, then go to the table or a diagram, find out the transition q naught on the input of b. What is the transition you need to find out? Then q1 comma b, what is the transition? So here q naught comma b is, it is q naught itself, union q1 comma b is q2. Okay, so if you take the union for these two, you will be getting q naught comma q2. So we got some new state which is called as q naught comma q2. So what is the first state? We got this one, and for input symbol b, we got this one. Among these two, which is new? Q naught comma q2 is new. Okay, already we processed for q naught. Now we are processing for q naught comma q1, and then we need to process for q naught comma q2. Okay, so for the state of q naught comma q2, same you need to find out from the transition table of given NFA. Okay, so q naught comma q2 on the input of A. Expand it and write. How to write this? Q naught on the input of A, q2 on the input of A. Find the transitions. If you find the transitions, then it is, so find the transition, then it is q naught comma on the input of A, it is q naught q1, union q2 on the input of A, it is null. So union of these both, we will be getting q naught comma q1. Similarly, for the input of B, you need to find out. Find the sandbox, sandbox product. Hmm. Q naught on the input of B, and Q2 on the input of B. So Q naught on the input of B, it goes to Q naught itself, and Q2 on the input of B, it goes to null. Okay, so Q naught union null, which gives Q naught only. So what is the state we got? Q naught Q1, and for the B transition we got Q naught. Okay, so Q naught Q1 is already processed. Q naught is also already processed. So no other new transition. When there is no other new transition, you have to stop the process, which means that we have found the NFA transitions. We have found the all the states of DFA. Okay, so we can able to stop the process. Next, we have to construct a table. So what and all we have found? First, initially we have taken Q naught on the input of A, we found that Q naught and Q1. On the input of B, we found Q naught. Then we have taken this state as a new state. On the input of A, we have found Q naught comma Q1. On the input of B, we found Q naught comma Q2. So this is a new state. So we again processed with this on the input of A and on the input of B. So we got a Q naught comma Q1 and Q naught. Okay, so make this as a table. Since this is a this containing two state, this is first state, second state, and third state. Since this is containing two state numbers, it will be looks clumsy and it won't look good if you draw the diagram. So we can able to rename the states. Okay, suppose I'm renaming this as, suppose I'm renaming this as hmm, A. Okay, so rename this Q naught as A, Q naught comma Q1 as B, and Q naught comma Q2 as C. Okay, so wherever Q naught comma Q1 comes, what it is? It is B. So we have to write it as B. So this is also B. Okay, so here also B. And here Q naught we are representing as A. So here also A, here also A. And it is Q naught comma Q2, it is C. So this is your table. Okay, so this is the final table. Whatever the start state will be the start state of GFA. Whatever the final state will be the final state of NFA. So in the final state, the Q2 is the final state. So where and all Q2 comes will be the final state. Q2 comes here, and Q2 comes in C, state C. So state C will be the final state. Okay. So So whatever we found in the last slide, we have taken the transition table. By using the transition table, you have to find the DFA diagram. Conversion of NFA diagram to DFA diagram. So there are three states. If there are three states, you draw it horizontally or draw it like a triangular box. So whenever a diagram, DFA diagram or NFA diagram, draw it in a neat way. Okay. So if they are giving, say for example, if you are using four states, then square you can able to draw. If you are having three number of states, then triangular shape you can take. If five number of states, then hexagon. So like that, don't draw it wherever you want. Okay. So draw it in a neat way, which gives you a diagramic look. Okay. So there are three states. So horizontal way we have taken. So in the horizontal way, on the input of A, it goes to B. So on the input of A, it goes to B. A on the input of B, it goes to A. So itself, A on the input of B, it goes to A itself. So itself means it is a loop. Okay. So we have represented it as, we have showed it as a loop. Then similarly, B on the input of A, it goes to B only. So it is a self loop. And B on the input of B, it goes to C. So C is another state. So we have showed the transition C. Then C on the input of A, it goes to B. And C on the input of B, it goes to A. So it is a backward transition. Okay. From C, it is going to backward transition. So mostly these are all the difference between your NFA and the DFA. You may not see the backward transition, or you cannot able to see the for a same input many number of transition in the DFA. Okay. So if you are seeing such things, then it is a NFA diagram. Okay. So in NFA, you will be having many transitions and you won't be having the backward transition. In DFA, you may have the backward transition and you won't have the repeated transition for same input. Okay. So these are all the difference. And you have to write, apart from that, you need to write like a diagramic, you need to write with the logic, like all the tuples, whatever you need to mention for the what we found the DFA diagram. So in the DFA also we have five tuples. So all the five tuples you need to mention what is Q. Here we have taken Q or three states A, B, C. So A, B, C you have to mention. Summation represent the input alphabet. Here what are all the input alphabet A, B. You have to write that. Then which is the start state? A is the start state. Which is the final state? C is the final state. So everything you need to mention, and then you need to mention the transition table diagram neatly at the end of the answer. Okay. So next we'll see the epsilon NFA. So what is epsilon NFA? So as the name says, epsilon. So epsilon means it is a empty. Okay. So in the NFA transition, you will be having the empty transition. You will be having empty transition from one state to another state. So when there is a event, when there is a some event is happening, you will be having a transition from one state to another state. Okay. So here this in epsilon NFA, without any event is happening in a diagram or happening in a model, you can able to have a transition from one state to another state. Okay. So that is the speciality of epsilon NFA. So if you have a switch, okay, switch will be considered as a model of a finite automata, right? So if you have a press, if you are pressing on, that is an event. So if you press on, it goes to on state to off state. If you press off, it goes to on state, it goes from off state to on state. So like that, there is without any event, it won't occur. It won't have any transition from one state to another state. But here in epsilon and FA, we have that. Okay. So without any event, we can able to travel from one state to another state. That is called as epsilon NFA. So if there is empty transition along with the NFA, then it is called as epsilon NFA. Okay. So as the name said, NFA, we can able to have for the same input many number of transitions. Okay. So that can be included in the NFA. Okay. So in the NFA, empty transition, if it is there, then it is called as epsilon NFA. So here we have taken one example problem. So this is a little big problem. So we have taken a big problem only, so that you can able to solve some small ones. Okay. So sometimes they will be giving the table. I think in your model paper also there is one given table. You need to convert into the epsilon NFA to DFA. Okay. You need to convert into a NFA. You need to convert into a DFA. Some other transitions they will be giving. So, sometimes they will not mention that, they will mention NFA only. Okay. So in the given table, if it is epsilon is there, then it is obviously epsilon NFA. Oh, okay. So here you can see that there are states from 0 to 7. Here the epsilon transition from 0 without any input, you can able to travel to 1. Okay. From 1 without any input, you can able to travel to 6. Okay. So like that, we have some epsilon transition in this diagram. Okay. So what we are going to do, we are going to convert the obtain a DFA for the epsilon NFA. So in the previous problem, we saw that NFA to DFA construction. Now epsilon NFA, if suppose epsilon NFA is given also, you need to convert into a DFA. Okay. So in DFA, what should not come? The repeated transition should not come, and epsilon also should not come. So you need to eliminate the repeated transition for the same input, and you need to eliminate the empty transitions also. Okay. If you eliminate these two things from the given diagram, then you can say that this is a DFA diagram. Okay. So to do that, first you need to identify, same way, in a similar way, you need to identify the start state of your NFA in the given thing. So in a given, what is the start state? 0 is the start state. So will be the start state of your DFA also, whatever we are going to find. So the start state of NFA is given thing is 0. So for that, you need to find the E close. Okay, which is nothing but epsilon closure also we can say, or E close also we can say, epsilon closure or E close. So to find that E close of 0, suppose if it is small number, you can if you want to find out all the state, for all the state, if you find out, that will be more easy. Problem. If it is more number of states, I am going to find it out whenever I need. Okay. So if it is small problems, or in your exam, you better practice uh, first in the initial state itself. You find the E close for all the states. Okay, that will be more easy, and it will be helpful to which will be helpful to convert in the upcoming process. Okay, this is like a hint or a note you can take. Okay. So initially, if you found the E close for all the states, for 1 also you find, for 2 also you find, 3 also you find, every state. If you find, it will be easy for other constructions. Okay. Since it is more state, I am not finding here. For this particular problem, I am not finding here. Okay. So first I found only for the start state. What is the start state? 0 is the start state. So we need to take that epsilon closure, E close of 0. Okay. So what is E close? E close means epsilon transitions from the given state uh, through epsilon, where and all you can travel in the diagram. Okay. Where and all you can able to jump. Okay. That you need to find out, which is called as E close. Okay. So from 0 through epsilon, I can able to travel to 1. Okay. From 1, on the input of epsilon, you can able to travel to 6. Okay. With empty transition, you can travel to 6. From 6 empty transition, we need not to travel anywhere. Okay. So what are all the places we can travel? From 0 to 1, 1 to 6. So that's why I have written the E close of 0 is 0 comma 1 comma 6. Okay. So always whenever you are finding the E close, first include that particular state. That is always better. Okay. First you include that particular state. So I will show you how uh, 2 3 other state also, how you can able to find out. Say for example, we'll take one. So e close of one you take. So how to find that? First, you need to include that particular state. Don't forget that. Okay. So include that particular state. One means from one you need to include that. Apart from one, what all we can there and all we can travel, you need to find it. From one, I can able to travel to six through empty transition. I can able to travel to six. So include six. From six, where you can able to travel, from 6 on empty transition, no other transition. So finish it off. Okay. So this is the e close of 1 is 1 comma 6. Okay. Similarly, you take e close of 5. E close of 5. So include that state first. Okay. 5 you have to include. From 5, where is the, one second. From 5 empty transition, it is going to 1. Okay. From 5 empty transition, it is going to 1. From 1, it is going to 6. From 6, nowhere we are going. So e close of 5 is 5 comma 1 comma 6. So like this, if you find for all the state, it will be very easy to do the problem. Okay. um, I'll clear it, close it. Okay. So we'll go for the next step, next slide. So after finding that, then in a similar way, the start state we have taken in NFA also, finding NFA to DFA. From the start state only we found the, we have applied the formula. Okay. From the start state, here the start state is whatever we found, E close of 0. Okay. So what we found, E close of 0, E close of 0, we found that 0 comma 1 comma 6. Okay. That I have named it as A. Okay. Here itself I have named it as A. So A on the input of A you have to find, A on the input of B you have to find, and A on the input of C you have to find. Because these three are the states of the given epsilon NFA. Whatever the states of the given epsilon NFA will be the input for the DFA also. So all the states we need to consider. Okay. So on the input of A, if you found that epsilon, this is the states. On the input of A, is there any transition you need to find out? So 0 on the input of A, no transition. 1 on the input of A, no transition. Then 6 on the input of A, no transition. So everything is null. You will be getting null only. Okay. Second, you take that A on the input of B. Okay. So 0 on the input of B, yes, we have, which is it goes to itself. So 0. Okay. So we have mentioned 0 here. Then 1 on the input of B, it goes to 2, it goes to 1 on the input of B, it goes to 2 comma 4. So we have taken 2 comma 4. Then 6 on the input of B, it goes to 7. So what are all the things we have got, which is 0 comma 2 comma 4 comma 7. Okay. So if you got these many, you need to, if you got any state, you need to find the E close. Okay. E close of 0, E close of 2, E close. Don't forget to find the E close. If you are not finding E close, then this state will not be the correct state. Okay. In the conversion of NFA to DFA, we will not finding the epsilon closure and all. Whatever the transition output we got, that we will be taking as a new state. But in E close, you have to find the whatever the new state you got, you have to find for the new state epsilon closure, and then that will be considered as a new state. Able to understand? So this is the extra step you need to follow by comparing the NFA to DFA, epsilon NFA to DFA. Okay. So here epsilon NFA you need to convert. So what is that? E close of 0 comma 2 comma 4 comma 7. So E close of 0 we already know. What is that? 0 comma 1 comma 6. E close of 2, similarly E close of 2, there is no epsilon transition from 2. There is no epsilon transition from 4. From 7 also no. Mm, sorry. E close of 1 0 1 6 we need to find. E close of 0 2 4 7. Okay. So E close of 0 is 0 comma 1 0 comma 1 comma 6. So that we have to include 0 comma 1 comma 6. Then E close of 2. E close of 2 is, there is no transition for E close of 2. Then E close of 4, there is no transition. Maybe. So whatever the epsilon closure of 0 comma 2 comma 4 comma 7. Okay, so you need to find for all the transition and make a union operation, and then you will be getting these many numbers. So here it is E close of 0. 1 second. So E close of 0 include that state 0 comma 1 comma 0 comma 1 comma 6. E close of 2 is null. E close of 4. E close of 4. Something is E close of 4. E close of 4, there is no empty transition. Then E close of 7, I think 1 second. Hmm. Front, I think diagram something. Okay. Okay. I'll take another input. 1 second. Okay. So here B on the input like this, that is the logic here. B on the input of A. Okay. So whatever we found from the last input, whatever the we found from the last input, this is the state. Okay. This is the new state we have got. For this new state, we have to process. So before completing, we have to find that on the input of C also. So on the input of C, we got that 0 comma 1 comma 6. Okay, on the input of C. So on the input of C, where and all the transition, it is null. Here 0, there is no input transition for C, and the input transition for C here from 1 also it is null. Then from 6 also it is null. Okay, so it becomes null. So since we got the B transition, we are going to consider the state B. For the state B on the input of A. Okay. So for the state B on the input of B on the input of C, we need to find out. Okay. So on the input of A, it goes to 3 comma 5. Okay. So from this state, from 0 on the input of A, there is no A transition. From 1 on the input of A, no A transition. From 2 on the input of A, there is A transition. So it is 3. Okay. So it goes to 3. So we have given 3. Okay. Then 4 on the input of A, it goes to 5. So we have given 5. Then from 6 there is no A transition. From 7 also there is no A transition. So only we got 3 comma 5 as the in outputs. Okay. So E close we need to find out. So E close of 3 comma 5. So what is the E close of 3 comma 5? So which is you need to find out that E close for 3. So you have to include E close of 3. You have to include 3 first. From 3, what are all the epsilon closer you need to find out. Um, from 3, there is no epsilon closer, so only 3. Then union epsilon closer for E close for 5. Okay, so E close or 5, you include that state. So 5 it will be. Then you will be getting from 5 it goes to 1. Epsilon will goes to 1. From 1 it goes to 6. So from 6 there is no epsilon transition. So union of these two you will be getting 3 comma 1 comma 6. Okay, so 3 comma 1 comma 5 comma 6. So you arrange it in a order 1 comma 3 comma 5 comma 6. So you will be getting 1 comma, so you'll be getting this as a new state. Okay. So this state you have to consider as C. Okay. Similarly, you find for B. Okay. Input for B, you will be having these many transition. Then find for all these state E close, you need to find E close of 0, 0 comma 1 comma 6. For 2, it is null. So even, sorry, even if it is null also, that's why we have included the um, states in the previous slide also. That's why we have included that. You need not to, you should not forget that. So here also, even if it is null also, you have to include that particular state. So you have to include 2, and you have to include 4 and 7. So 0 comma 1 comma 6 along with that 2, 4 and 7. So only we got that 0 comma 1 comma 2. Okay. Then I'll clear the drawings once again. Okay, so you got the particular some new state. Keep it aside. Then you have to find for B. If you find for B, you will be getting this many states, and you got the B as the new state. Okay, so whenever till you get the new state again and again, we need to follow the same procedure. So B on the input of C. So let's do B on the input of C. So here it is from the state 0, the B input it goes to C input. There is no there is no C transition on 0, so null. From 1, C transition is null. Then from 2, C transition it goes to 3. So we have to write it as 3. Okay, 3 comma. Then from 4, uh, C transition null. From 6, C transition is null. From 7 also C transition is null. So we got only the state um, 3. Okay. So after finding this, we should find the E close. Okay. So E close of 3 means you should include 3 at the beginning. Okay. Then find the transition for empty. From 3, there is a empty transition. Is there any empty transition? No. So there is no empty transition. So 3 will be the final. E close of 3 will be, this will be the final. Okay. So this E close of 3, you got the answer is 3 only. So 3 is a new state. Again, 3 is a new state. So we have named it as 3 only. Okay. Then up to B we found. Now we have to find for C, D and E. Similarly, you need to find for C, D and E. So for the state C, okay, you take the state C. On the input of A, you need to find it is null. So epsilon close of null also will become null only. Okay. So E close, sorry, transitions from on the input of B, you need to find. So you will be getting 2 comma 4 comma 7. So E close of 2 comma 4 comma 7 you need to find. epsilon closer from 2, it is null. So we have to include only that state. Okay, 2 we have to include. Then epsilon closer of 4 is also null. So 4 you include, only include that particular state. E close of 7, so include only that particular state. Okay, so we have got 2 comma 4 comma 7. So again this is a empty state, this is a new state. Okay, so since this is a new state, you have to name it as F. Up to E we have found. So now we are naming it as F, new state. Then similarly C, on the input of C you are finding, you will be getting 1 comma 6. So what is the epsilon close of 1 comma 6, which is 1 which you got 1 comma 6 only. So name it as a G, as a new state. Similarly, you need to consider the state D, find for A, B, C. Okay, find for A, B, C, and you are getting a repeated state. So if you are getting a repeated state, you need not to find out, just name it and keep it. That's all. So you are getting a new state up to H. Okay, so up to H you will be repeating the same problem, same type of finding the transitions. Okay, so once all the state is done, you are getting a repeated state for all the state you have found. Up to I have found. So after the I did not get any new state, then I should stop the process. Okay, so then I should stop the process. So here the all the states you have to list it out. First state is A, we have named, which is 0 comma 1 comma 6. Okay, why we have named it as A? If you are mentioning all these 0 comma 1 comma 6 in the state diagram, it looks awkward and it looks messy. Okay, so for that we are mentioning the, giving the renaming. Okay, so this we are taking it as A. Okay, for A state, B state, up to I state we have. Okay, so we'll see what is the transition diagram. So on the input of A on the input of A, what is the transitions you have got in the beginning? I'll show it. So on the input A, on the input of A, we got null. On the input of B, we got B as the transition, then null. So null, B, null will be, will you have to fill the uh, table in that way. Okay, so A on the input of A, it is null, it is B, and it is C. So see the transition, what all we are getting, we need to fill like that. Okay, so I'll show for one more thing. For D you take, for D on the input of A, B, C. Suppose D on the input of hmm, D on the input of A, B, C, what we got? C comma D comma H, C, D, H. So you have to mention in the table C, D, H. So that's why we have mentioned C, D, and H. So like this, you have to fill all the states. How many states we got? A to I we got, and the 3 inputs we got. So you have to fill like that. So what is the start state? A is the start state. So A will be the start state. And here the final state. There in the given NFA, epsilon NFA, what is the final state? 7 is the final state. So which are all the states which is containing 7? See, F is containing 7. Then, hmm, see, here B is containing 7, D is containing 7, and F is also containing 7. So B, D, and F are the final states. So B, D, and F are the final state. So by seeing this transition table, you have to construct a transition diagram. So your transition diagram, since it is many states, you will be getting a diagram like this. Hmm. So difference, next slide, you have to write the, by seeing the transition diagram, you have to write the transition, transition table, you have to write the transition diagram. On the input of A, there is no transition. On the input of B, it goes to B. So B you have to write. See here, there are 2 circles. It is representing a final state. So here B, D, and Here F will be the final state. Okay, and you have to draw the diagram in any way. Then difference between the DFA, NFA and epsilon NFA. This is a theory question. It may asked in 4 or 3 marks. Uh, the transition function is the only difference. So Q cross input alphabet, it leads to Q, one state only. The transition will happen to one state. Here the transitions will happen to the many number of states. Okay, so that's why it is represented as 2 power Q. Okay, here the transition will go to many number of state, and also it has the empty transition. So in the input symbol along with A, B, C, empty also will be included. So summation union empty, which leads to many state. Okay, so Q here Q cross summation, which represents the Q represents the input state, and summation represent your input alphabets. So combination of these two will lead to many number of states. And here zero or one transitions. As I said, one transition only permitted. Here zero or one or more transitions are permitted. Here also zero, one or more transitions are permitted. So more number of transitions. Here we will be having it is easy as like that. Here we can see that the DFA, you have to think logically a lot. Okay, then only you have to construct. But here whatever given in the question, directly we can able to construct NFA or epsilon NFA. So it will be more easy compared to your NFA, DFA. Okay, and since it is here easy, and here also here the NFA and the epsilon NFA will be more powerful than compared to your DFE. Okay. So up to this, we'll wind up. We'll take a lunch break for 45 minutes. Then we'll come for the rest of the topics in first module. Okay. Is there any doubts? You please message in the chat box.
All of you, please join back to the meet once again exactly at 1:45. Please attend the class because it is a minimized version of a presentation for your final exam. So try to log in exactly at 1:45. Okay. Till that time, you will have a lunch break. Thank you all for attending the class.
Thank you.
Good. Answer பண்ணிட்டு அதுக்கு போயிட்டேன் நானு. Until when we need to find the states of DFA, like here we stopped at I. Till you don't get new state.
Chat answer
Ah. Two questions.
start from the
பசங்க வர மாட்டானுங்க. சிஓக்கெல்லாம் எங்க வர பண்ணுங்க. நீ நம்ம சிஓ எடுத்துக்கோ. Who's aims education? Who is messaging? என்னடி இது? SVG தான் மெசேஜ் பண்ணுங்க. SVR Please share PPT. Tell them after end of day. Okay. We have taken examples of model question paper.
Devi ma'am. Devi ma'am. You are not muted, Devi ma'am.
லாக் அவுட் பண்றதா இருக்கிறது அப்படியே தெரியல என்ன பண்ணு அப்படியே இருந்துட்டு போதுவா ஜாயின் பண்ணனும் நம்ம லாக் அவுட் பண்ணுவோடி
Devi.
Devi ஹலோ ஹலோ
இருக்கட்டும் நீங்க அதை மியூட் பண்ணி வச்சிருங்க அவ்வளவுதான்.
ஒரு நிமிஷமா ஹலோ
மியூட் பண்ணு போதும்.
சரி சரி மேம் ஓகே
நான் இங்க ஆன்ல தான் வச்சிருக்கேன். சோ நீ மியூட் பண்ணா போதும்.
சரிங்க மேம் ஓகே மேம் தேங்க்யூ மேம்
ஓகே மேம் பை.
This is Dr. Lata, heading Computer Science and Engineering Department in AMCEC. Over the past 2 decades, the department has grown leaps and bounds to become one of the pioneer departments under VTU by securing 11 VTU ranks. We pride ourselves in academic rigor, excellence, discipline inculcated to the students by a highly qualified and experienced set of faculty members, among which many are doctorates and actively pursuing research.
Hey, I'm Shayan. And yeah, the classes can get boring at times, but the faculty at AMC emphasize creative learning with ICT tools and project-based learning. Each faculty provides their own web link where you can access course content, notes, and other material. For the latest academic content, the department has its very own app called Course Smart. Our students have won numerous accolades, including the Best Student Award under ISTE, and even recognition from NASA. Yep, the one in the USA. We even have our own forum, the Intellects Forum, which is of the students, by the students, for the students, with guidance from the professors, of course. Under the forum, we conduct numerous technical events, non-technical events, and even exciting brainstorming sessions. We think you're going to love them.
We are near one of the 12 labs under the department, among which 2 are centers of excellence. One is by well-known Cisco for networking, another one is by TechVet for Internet of Things. It also has 3D printing technology to make your product ideas come into life. We periodically conduct international conference, hands-on workshops, faculty development program to keep both the faculty and the students abreast of the industry requirements like blockchain technology, augmented reality, edge computing, so on.
Hey everyone, I'm Shravani Ghosh, an undergraduate student at AMC. We are home to a community of leading research and teaching. This place right here is where we usually have our lab sessions along with value-added certification programs like AWS, Blue Prism, Cisco networking and many more to make you all industry ready. Okay, now if placements are a concern for you, let me make it clear that our college provides industry-specific upskilling along with the personality development and software training. Okay, this makes it easier for the companies to hire you. You just gotta make sure you meet the eligibility criteria, that's all.
Dear participants, we'll start with in another 5 minutes. We'll wait for 5 minutes, then we'll start the session. Okay. Good afternoon, everyone. We'll start with the session. Next topic we need to see is minimization of DFA. So if you have any doubts in the previous topics, you please ping me in the chat box so that we can clarify now only. Okay. So minimization of DFA. This why we need to minimize the DFA. Okay. So first we need to see that. So here we what are all the applications of finite automata? Basically, we are designing a model, abstract machine. Okay. So that will be converted into a circuits, or this will be used in a compiler design, or this will be used in assembler, compilers, and everything, right? So these automata. So if you are constructed a DFA, or if you are constructed a finite machine with many number of states, okay, so it will become unnecessary, or it will become more it won't be more effective, and cost wise it will be very high. Okay, so to reduce that, we will be using such automatas in circuit designs and all, everything. Okay, so to reduce, if you are removing the unwanted states, or repeated states, or repeated number of transitions, we need not to show that in the DFA or in the finite state diagram. It can be any finite automata. Okay, so if you are giving that in a minimized manner, then the outcome also will become easy, so that we can able to reduce the cost also in the designing part. Okay, so for that reason we are having the minimization of DFA concept. Okay, so when there is a when the DFA is very big, we can able to minimize it, we can able to minimize the number of states. Okay. So how we can able to minimize the DFA? There are steps you need to follow. Okay, so for each and every problem like this, you'll be having a steps. Okay, you have to go through that before going to the exam. Okay, keep it as a notes, or any assignment like a kind. You just go through these steps before going to the exam. That will help you to find out the formula and everything. Okay, then the first step is divide the Q. What is Q? Q is a set of states. Divide the set of states into two groups. Okay. So first of all, we are going to divide into two groups. One group is non-final state. Another one is final state. Okay. So one is non-final and another one is final state. So that we are going to naming it as G1 and G2, group 1, group 2. Okay. And then we are going to find for different iterations by applying the input. Okay. As like the other problems, here what we are going to do for the states, we will be applying the input and find the transitions, right? The same kind of thing here also, we are going to find the different set of pi values. So what is this pi representing? That different iterations. Okay, so these different iterations, how we are going to find out? By applying the different set of inputs like A and B. If you have as a input, you have to apply A and B for the initially divided groups. Okay, which is final states and containing non-final state. If you are having 0 1 as the input, then apply 0 1 as the inputs in the states, groups, whatever we have found. Okay, so that this, when we have to stop the process, you need to find this state when you are reaching the pi k minus 1 and pi k, which means the last uh, transitions, and last but one transition. Okay, if both these two iteration, pi k minus 1 value and pi k value, if both are same, we need to stop the process. Okay, so these are all the important points you need to uh, keep remember. Okay, so all the states in the group, which if it is enters. Okay, so how we are going to find this? By applying the input. Okay, so you need to find that whether initially we have got two groups, group 1 and group 2. So from the group 1, what are all the states which is falling into another group, we need to find out. Okay, so if all the states present in group 1 falls into another group, then we need not to split it. This is one important point. Okay. So if how we are going to find the pi values, different pi values, we are going to apply the input. Okay. Apply the input into the group. Okay. So initially two groups are there. From that group, apply the input, and you need to find out where in which group the output is falling. Okay, So if all the groups, if all the in the group one, if all the states falls into another group, then no need of splitting. Otherwise, you need to split it. Okay. So when you are, if some you have in group one, you have 5 states. Okay. First two states are falls into another group. The next two states are falls into some other group. Then you need to split. Okay. So if all the states are falling into the same group, you need not to split it. So this is the important point. So here, when we are keep on splitting like this, you will be generating a different group. Okay. So when you are getting a different group, again the iterations you need to repeat. You need to repeat the iterations, repeat the procedure until you get the pi value, pi k and pi k minus 1 are equal, until you get the pi k and pi k minus 1 are equal. Okay. So this is the steps you need to follow. So you need to apply the apply the inputs repeatedly, which means alternative way. For A, in the previous groups, if you are applying A, next you need to apply B, next you need to apply A. So like that, you are going to apply the input and you are going to find it. Okay. So let's see, take one problem and we'll see how it is working. So obtain the distinguishable state for the automata. Here, to minimize the DFA, they have given the table. Okay, to minimize the DFA, they have given the table. Okay, so you can see that these many states. So in the DFA, it is having A, B, C up to H. So it is having almost 8 different states. Okay. So among the 8 different states, which are all it is repeatedly or it is unwanted, okay, we can eliminate those kind of states. So how we are going to process this? By applying the input and find the different set of iterations like pi 0, pi 1, pi 2. So until you get to the groups are same. So you can see that the pi 3, okay, containing 5 groups, and pi 4 is also containing 5 groups, and both the groups are same. So when you get such iterations output, you have to stop. Okay. So here pi k up to pi k we found the pi k minus 1 is same. These both are same. So when this such type of output comes, you need to stop the process. Okay. So first initially, what is the initial condition? You need to divide the states into two groups. So first we are going to divide the state into final state and non-final state. So final states are C. Okay. Non-final states are all other apart from C, which are all non-final state. So take group 1 and group 2. Okay. So apply the input A. Okay. So in this group 1 and group 2, which is considered as pi 0. So in this, we are going to apply the input A. Okay. So on the input of A, what all the transitions happening in group 1, we are going to see. So for the input of A, it goes to B, G, okay, G, B, G and all itself. It is comes under group 1, okay. So group 1 is itself. And D on the input of A, it goes to other group. So D is falling to other group, okay. And E on the input of A, it goes to H. H is belongs to group 1. So itself, it is a itself. It is falling to the group itself. Then G is goes to G. Okay, so it is also itself. H is also G only, so it is itself. So only D and F. So here you can see F is falls into C group and D is falls into C. Okay, so C is a group 2. Okay, so only these two belongs to other group. So we have to segregate these two as one group. So you will be getting A, B, E, G, H as group 1, and D and F alone. This D and F will be group 2. Splitting is required because each and every element, if all the element falls into C, if all the elements falls into itself, then no need of splitting. If some elements falls into other group, then we need splitting, right? So we are splitting this groups. So G1, G2 and G3. Okay. So in this, we are going to apply the input B. Okay, so apply the input B, you will be getting F. F is G2 group, so keep it as it is. Then B is C group, then E is E is E is F group, so it falls here. Then G is E, so it falls to itself. Then H is C. Okay, so here we need to split that this A and E. Here you can see that A and E, it is these two elements, it is falls into this group. Okay, so you segregate this B and H, A, E and G. A, E and G, it falls into the group itself. A, E and G. Okay, so on the input of A, it falls into the group itself. The other two elements, B and H, B and H, you can see it falls into C group. B and H, it falls into C group. So we need to split that B and H alone. Okay, so this A, E and G, here one arrow mark I forgot to put. Okay, B and H is falls into other group. A, E and H is itself. So we need not to split this, keep it as it is. This you need a splitting. Okay, so B and H we are splitting it. Okay, so you will be getting group 1, group 2, group 3, group 4. Okay, 4 groups you have got. Similarly, again you need to apply the input for A. A on the input it goes to B group, G2 group. Then E on the input it goes to G2 group. G on the input it goes to itself. So only this belongs to itself. These two goes to another group. So there this group needs a splitting. If all the element goes to some other group, if all the element falls to itself, we need not to split it. Okay. So here in group 1, we have 3 states, A, E and G. Okay. We have 3 states. These 2 elements falls into some other group. This element, this state falls into some other group. So we need splitting. Able to understand? So we need the splitting. So G1 from this group we are splitting A and E, and from G will become another group. So AE, G, BH, DE and C. So these are all the 5 different groups we got. In this again we need to apply on the input B. So you apply on the input B, A on the input of B, it goes to F. E on the input of B, it goes to F itself. So A and E, both it goes to group 4. So if both it is falling into same group, we need not to split it. Okay. This is already one element only, so no splitting is required. Okay. So when there is minimum at least 2 elements should be there, then only you need a splitting process. Otherwise, you need not to do anything. So here B and H is there. Apply the input. B on the input of B goes to C. H on the input of B, it goes to C. So B and H, both it is falling to group C. Okay. Both it is falling to group. So no need of splitting. Then D and F. You take D and F. D it goes to G and F it goes to G only on the input of B. Okay. So G means G, it is a group 2. So D and F, both it is falling to group 2. So no need of splitting. Okay. So we will be having the same group again. So what it is? G1, G2, G3, G4 and G5. Okay. So if the previous iteration values, groups and the last iteration groups, if both are same, we need to stop the process. Okay. So like this, you need to find out for all the iterations. Okay. Then you need to construct the table. So what are all the states we have found? Groups we have found, which are these are all the states of the minimized DFA. Okay. So group 1, group 2, group 3, group 5 we found. So all these we have So all this we have written as a table AE, B, BH, C and everything. So AE on the input of A. Okay, just see the diagram and you can able to write. So AE on the input of A. So A it goes to B. B is which group? B comma H. So you have to write B comma H. Okay, so here only the table is there, you can see here. BH on the input of A. So BH on the input of hmm. So B on the input of A, it goes to G, and you need not to see the second element. If we already segregated, no, so it will be falling into the same group only. H will fall into G only. That's why we have written BH as a group, right? So directly write. If you see one element, you can write the group itself directly. No need to see the third element or second element. Okay. So C on the input of A, it goes to C on the input of A, it goes to A. A is a group of A comma E. So you have to write A comma E. Only C, it goes to A only, but you have to write it as A comma E. A is belongs into the group called A is belongs to the group called group 1. So group 1 we have to write it as A comma E only. Then D comma F on the input of A. D on the input of A, it goes to C. So write C. C is a single group, single element group. So write C only. G on the input of A, it goes to G. So write G as a single element. Similarly for B, you have to see. So A on the input of B, here it is F. F comes under DF group. So you have to write DF as a group. Okay, both the values. Then these are all the 5 different states, minimized states. So earlier we had 8 states. Now we are having 5 states. So this is the minimized DFA diagram. If you want to rename it, you can rename. Otherwise, here it is only 2 elements. Then you can write the same element as a DFA diagram. Okay. So 5 states, write 5 states and draw the diagram A comma E. On the input of A, it goes to BH. So on the input of A, it goes to BH. On the input of B, it goes to DF. It goes to DF. On the input of so B comma H, on the input of A, it goes to G and it goes to C. Then on the C state, input of A, it goes to AE. Input of B, it goes to itself. So it is a loop. Okay, itself. So like that, we need to draw the DFA diagram. Able to understand this one? You need any clarifications? Please put it in chat box. Okay. If you need any clarification, you message us in the chat box. So next one is finite state transducer. So finite state transducer, where here you can able to here the finite state machine, you can able to accept, give some input, it will whether it is accepted, the result you can see that whether it is accepted or rejected. Okay. Apart from that, you cannot able to see the see any other output coming from the finite state machine. Okay. So here in finite state transducer, apart from that, whether it is accepted or rejected, we can able to count, say for example, in some problem, we can able to count the number of AB pattern is occurring, or count the number of zeros are occurring, count the number of ones are occurring. Okay. So like that, we can able to analyze some more things, some more details about the input. Okay. So that is called as transducer. Some more in detail information we can able to get about the input, about the input string in the automata. That is called as transducer. So in this transducer, we have two kind of machines. One is Mealy machine, another one is Moore machine. Okay. So in the Mealy machine, here as I already told that the output will be apart from accept and reject, some kind of output you will be getting. Okay. So you can convert the values, you can able to get the count, everything. Okay. So the output, if you have associate the output within the transition, which means in the diagram within the transition, if you are giving the uh, within the edge, if you are giving, then it is called as meal emission. In the transitions, if you are showing the output, associate the output in the transition is called meal emission. If you are showing the, if you are giving the output, if you are adding the output in the state, okay, in the state is called as more machine. Okay, so if the output is associated with the transitions, it is called as meal emission. If the output is associated in the states, it is called as more machine. Okay. Then all the tuples, everything is same. So what is the difference? I told that it is along with the out, we will be having the, accept and reject, we will be having some kind of output. So output alphabets we will be having in the mealy machine and in the more machine. Okay, so here uh, so for that output alphabets, we will be representing that in terms of the symbol called tau. The T like symbol, it is called as tau. So it represents the output alphabets. As like the input alphabets, we have some output alphabets also. So you can able to use either 0 or 1, or you can able to use true or false, T or F, you can able to have like that. Any characters if you want to have, you can able to have this as a output alphabets as like your input alphabets. Then we'll be having a lambda, this lambda function which represents the transition function, output function, transition output function. Here how we have the input symbol, the input transition will represented by delta symbol. Like that we have output alphabets, the output transitions will be represented by the lambda symbol. Okay, so like how you have the transition function as from the state input alphabet which goes to another state, same like that here. From the state it goes to, it takes the output alphabets and it goes to another state. The transition function also same here. Instead of that epsilon, instead of that summation, you will be you will be getting tau symbol, then it is called as output functions. Okay. Hmm, input function and output functions. So we'll take one example. Construct a mealy machine which accepts the A's and B's and count the number of times the pattern AB is present in the given string. Okay, so you need to you need to count the number of patterns uh, in the string whether AB is appearing. Okay, how many times the AB is appearing. Okay, so in the DFA you might have designed such problems which is ending with AB or starting with AB or substring AB. Okay, so like that any problem you can able to take, any DFA you can able to take, that DFA should contain the pattern AB. Okay, so we have taken this DFA contains pattern AB. Okay, so it has three states. We need to take the input, the mandatory cases AB. So since it is two characters, I already told you there are three different states. Okay, Q0, Q1, and Q2. So from state A, that is A transition. From state B, B transition, and it goes to accept. Why it goes to accept? Because AB is the pattern we want. Okay, so AB is the pattern and all other, this is the mandatory case. And all other transitions you need to show. Here Q not, A transition we have showed, B transition we need to see. Okay. So if AB is the pattern, it should come. They did not mention that whether it should be at the beginning or it should be at the end or it can be a substring. Okay. So we have given in Q naught state B as a loop. So any number of B then followed by AB also can come. Okay. So but here what is the condition? AB should present in the string. Okay. Then followed by in Q1 state B transition is there, A transition we need to show. So A transition it can be many in number. A followed by B also can come. So we have given the self transition for A. Similarly, at the end Q2 state A transition and B transition we need to show. So after B, if A comes, again the pattern will not come. So for that we have given the back transition for A and B to Q1 and Q2. Okay, so this is a general diagram DFA you can able to take to accept the pattern AB. Okay, so when it will accept, if you reach the Q2 state, it means that the string is containing AB. Okay, so if you reach the Q2 state, the string is containing AB. This is the case in the mealy machine. Okay, so as I said, in the DFA, if you are showing the output in the transitions, it is called as mealy machine. Okay, so here which transition is true? So if AB in Q2, after accepting in Q2, this transition A and B, this transition is true transition, which means the pattern is containing, if you reached Q2, the pattern is containing AB. So only this transition is true. Okay, all other transition we can able to take it as a false transition. Okay, so if you reach A, if you reach Q1, after reaching Q1, if you reach Q2, then in your string AB is containing, AB is present. It means that AB is present. So if you reach this particular transition, we can able to say that it is present. So present means we are taking either true or false or 0 or 1. As I said, any alphabet you can take it as a output alphabet. So here 1 represent the AB pattern is present. 0 means AB pattern is not present. Okay. So if it is 0, AB is not present. All other state we can able to give that it is 0. Okay. So B is the input, 0 is the output. A is the input, 0 is the output. Here B is the input, 1 is the output. Why 1 we are giving only for this state? Because after accepting B, it goes to Q2. So Q2 after accepting B means it contains AB pattern. So that's why we are representing this only for alone this state we are giving B transition. Okay. So this is your mealy machine. For any DFA, any finite state, if you add the output function in the transitions, it is called as mealy. You can able to find add any, you can able to take any different DFA diagram and you can able to show the output transitions, output in the transitions. Okay, so here they've given one example for to sequence. What is the input? A, B, B, A, B. Okay. So A, B, B, A, B. How we are going to count, as the problem says, we are going to count the number of times A, B is present. Okay. So how many number of times A, B is present in the string? A, B, A, B. There are two number of times. So we need to sequence, we need to process this. So if you process this, you can able to know that whether it is accepted or rejected. How we know that it is accepted? If you reach to the final state, it is accepted. Okay. Normally in the finite automata, we will come to know whether it is accepted or rejected. After accepting or rejecting, we can able to count the, we will get to know that how many number of times also it present. Okay. So Q naught on the input of A, Q naught on the input of A, it goes to Q1. Q1 on the input of B, it goes to Q2. Q2 on the input of A, it goes to input of B, it goes to Q naught. Q naught on the input of A, it goes to Q1. Q1 on the input of B, it goes to Q2. Okay. So right, they have processed it and write the output associated with the process. So on the input of A, what is the output is associated? A 0 is the output. For B to state Q2, 1 is the output. So for wherever the Q2 state, 1 is the output we are getting. So 1 we have written here. See the output 0, 1, 1, 0, 0, 1. Okay. So 1 and 1. How many number of ones are there? 2 number of ones are there. So 2 number of AB is present in the pattern. Okay. So like this, we can able to justify, we can able to analyze some more details about the string, some more details about the automata we can able to find out by using the mealy machine or the Moore machine. Okay. Same problem, AB to have the AB string in a DFA. Okay, how many number of times AB is present? The same set of problem. If you design the states associated within the state. Okay, if you design like this, then it is called as Moore machine. Okay, you can see that here in the previous diagram it has been mentioned in the transitions. In this diagram it is mentioned in the along in the states. Okay, so in the states it has been mentioned. So Q2 state is accepted state. So I for that not only the accepted state, it will accept if it has AB. Okay, so for that we have designed the we have given the output as 1. For other state, if it is containing, it is only A is present, not AB is there. So here it is 0. For initial start state also, the output is 0. Okay, so we have given in the state. So in the state, if you give that, then it is called as Moore machine. So one more problem for that same example, same Moore machine we've given, which is construct a Moore machine to produce the equivalent ones complement, okay, to accept zeros and ones. So the automata should accept 0 and 1. To accept 0, it goes to Q1 state. After accepting 1, it goes to Q not state. So accepting it will accept n number of zeros and n number of ones. Okay. So only two input is two output, two states is enough to accepting zeros and ones. So they did not give any condition whether 0 should be at the beginning or 1 should be at the beginning, or these many number of zeros should be there or 1 should be there. There is no condition, just accepting zeros and ones, and you need to find the complement of that. That is the condition. So here to find the complement, which means it should give some more output along with the whether it is rejected or accepted. Along with that, some more output it should give. So how you can able to design this, either by using Moore machine or by Mealy machine only. Okay, so it should show the output. So what are all the functions? There are 6 functions. You have to list it out properly, and you have to write all the functions. What is q, what is summation, what is tau. The input is alphabet is 0 1 means output alphabet also 0 1. What is the input transitions? By seeing the diagram you can write the input transitions. Output transitions, by seeing the diagram again we can able to write it. Okay, since the output I have given within the state, it is a Moore machine. Okay, so if 0 is the incoming transition, you need to change it as 1. What do you want? If 0 comes, what is complement? Just opposite is the complement, right? So if 1 is the 0 is the incoming transition, 1 should be the output. If 1 is the incoming transition, 0 should be the output. So we are giving associating for q naught 0, for q1 1 is the state, because here also we have 1. So it 1 to the q naught. So 1 to q naught should be converted as 0. So here also incoming state is 1. So it should be converted into 0. That's why we are giving 0 here, no, not a 1. Okay. So in this, both the incoming transitions are 0. So we are giving associating 1 here. Okay. So write the table by seeing the diagram and the transition. Here the output function. Here this is your input transition function. So transition table for the input and for the output. Okay. Take one input 0 1 0 0 1. So what should be your output? 1 0 1 1 0 should be your output. Just the complement of that. Okay. So 0 1 0 0 is 0 0 1 is the input. You should get the output 1 0 1 1 0 is the output. So we have got the same output. Complement of that will be the output. So Q naught on the input of 0, it goes to Q1. Just write by seeing the diagram. Q1 on the input of 1, it goes to sorry, it is Q naught. Okay, it is Q naught. Then Q naught on the input of 0, it goes to Q1. So like that, if you are changing the, if you are writing the, by seeing the transition diagram, you will be getting all the outputs. For that, whatever, wherever q1 comes, you need to associate the output as 1. Wherever q naught comes, you need to associate the output as 0. So we will be getting 1 0 1 1 0 is the output, just the complement of the input. Okay, so if the questions are asked like you need to show some output in the finite state, then you have to use. Sometimes they will not mention that whether you need to design a more machine or melee machine. Either anything you can design. More machine and melee machine does not have any difference. But you need to identify what they are properly asking, whether they are asking a output or not. If some kind of output they are asking, then it is a finite state transducer. So if they did not mention anything, then you can able to take the more or melee. Mostly more machine will be simple, because directly you are going to incorporate that into the state. Then it won't be no confusions. In the transition, you may have many transitions in the state diagram. If there did not mention anything, then you go for the more machine. But you have to read the question properly, whether they are telling you to design a finite state or finite state transducer. If they are associating any, if they are asking for some output, then it is transducer. If there is no output, then it is finite state machine. Okay. Is there any doubt? Some question and answer session is there. First question they did not mention.
See, actually, in the first question, okay, we have not specified, but the DFA, whatever we have design, no, that is the DFA for accepting the strings of A's and B, which ends with AB. If you don't have that condition, you can give the self loop on Q2. Okay. Since whatever DFA we have shown in the first question, that is the DFA to accept the string which ends with AB. As per that, you cannot give the self loop on Q2. If you don't have that condition, you can give self loop on Q2. Based on the question, you have to decide. Okay, thank you.
Okay. So up to this, we have wind up the module 1. Then module 2, Devi ma'am will be starting. Afterwards, I will be continuing with the module. Over to Devi.
Stop the screen share.
Yes.
Good afternoon to everyone. Now we'll start with the module 2. The module 2 is with respect to the regular expressions and the regular languages. I'll be starting with the regular expression concept. I'll be starting with the regular expression concept. Okay, first we need to know the definition of the regular expression. We can define the regular expressions recursively as, see, the regular expressions are defined based on the symbols. Okay, see, pi is a regular expression denoting a empty language. You need to remember, pi means it is a regular expression denoting a empty language, and epsilon is also a regular expression denoting a language containing a empty string. And if you have the regular expressions are R and S, consider two regular expressions R and S denoting the language accepted by the regular expression R and the language accepted by the regular expression S, then it is also a regular expression. If you have a regular expression R and regular expression S, the language of R and the language of S is a regular expression. And the that can be defined. If R and S are regular expression, R union S is also a regular expression denoting the language LR union LS. Here plus indicates union operator. R dot S means R concatenated with S is also a regular expression denoting the language R concatenated with the language S. And R closure is also a regular expression. If R is a regular expression and S is a regular expression, R plus S is also a regular expression. R concatenated with S is also a regular expression. Closure of R and closure of S is also called as a regular expression. This is a predefined definition of a regular expression which they ask in the question paper. Okay. And I told you the module 2 is with respect to the regular expression and regular languages. Okay. I have given you the definition of the regular expression. See, the languages which is accepted by the DFA, NFA and epsilon NFA, all those languages are called regular languages. The languages accepted by DFA, NFA, epsilon NFA, all the languages are called as regular languages. If you want to process regular languages, or if you want to represent a regular languages, that can be done with the help of a regular expression. So regular languages can be represented with the regular expressions. Okay. In the regular expression, in writing a regular expression, we'll be using a three operators. The first operator is place, that is union operator. It is used for denoting either the first symbol or the second symbol, either this or that. That is the meaning of this union operator in the regular expression. Next one is a dot operator, that is a concatenation operator. If you want to concatenate one symbol followed by the another, you can use a concatenation operator dot. And asterisk, that is a closure operator, we'll be using it. This closure indicates zero or more times. Plus indicates one or more times, but that concept we are not using in the regular expression. And we are going to start with writing the regular expressions for some basic examples. Then we'll go for a difficult examples. The first example for writing a regular expression means write a regular expression for the strings of A's and B's having a length 2. Strings of A's and B's having a length 2. That is a question. For that, I am just going to write a regular expression. I repeat the question. Write a regular expression for the strings of A's and B's having a length exactly equal to 2. That is a question. Okay. Now, if the input string is of A's and B's, what are all the possible strings I can write? AA, because the length should be equal to 2 means 2 A's I can write, 2 B's I can write, or 1A followed by 1B I can write, or 1B followed by 1A I can write. So these are all the possible strings of A's and B's with a length 2 I can write. Okay. Now these are all the possible strings. By seeing the question, you find out what are all the possible strings I can write based on the given condition in the question. So these are all the possible strings. Okay. So based on these possible strings, I'm just going to write a regular expression. See, either I can have 2A which is of length 2, or I can have a 2B, or I can have a AB, or I can have a B. I didn't specify how many A's and how many B's should be there. A's and B's can be in any number of combination, but make sure the length of the string should be 2. Okay. So there is all the possible combinations of A's and B's what I have written it, and length of all these expressions are 2 only. Now, if I want to specify this or that, what is the operator I have told you in the previous example? You can see. C plus is a union operator. This means that either this or that. Okay. So AA or BB or AB or BA. So I have written the union operator between all the possible strings, whatever I have written. Okay. So this is a regular expression. If you want, you can stop with this. But the reduced form of or the simplified form of this regular expression, what I can write it as A plus B concatenated with A plus B. Here I have not written dot. Okay. For concatenation, you can write it as A dot B also, or you can write it simply AB also. It is your wish. Concatenation, you can write it as A dot B or AB. Just AB you can write. Dot is not compulsory to specify. Okay. So this regular expression, I can rewrite it as A plus B or A plus B. It is not compulsory that you have to write this. You can stop the regular expression as this much itself. That is also fine. But if you know to reduce it, you can reduce it. This looks like A plus B, A plus B. I have written it. If you multiply this, you will get the exactly what is a regular expression, what I have written it before. Okay. I repeat, this is not compulsory to write it in a reduced form. If you want, you can stop with this statement itself. Okay. This is a regular expression for the strings having a length 2. Okay. A plus B 2 times it is repeated. That I can write it as A plus B the whole square. I can write it. Okay. So this is a final regular expression for the given question. And one more is like in the previous question, having a length 2 I have told you. Okay. Having a length 2 I have told you. But now here I'm just going to tell the regular expression which is having the length 0, which is having the length 1, which is having the length 2. The length can be 0, 1, 2, not exactly 2. It can be 0 also. 0 means empty. 1 also, 2 also. Okay, but not more than 2. Okay, so what I'm going to write is, first possible string based on the condition is, write a regular expression for the strings of A's and B's having a length less than or equal to 2 is a question. Okay, the condition is less than or equal to 2. So less than or equal to 2 means it starts from 0. 0 indicates it can be empty also. There is no A, there is no B. And length can be 1 also, it can be 2 also, or it can be like, okay, it can be 1 or 2, not more than 2 A's or more than 2 B's, or not more than 2 characters. Okay, these are all the possible strings what I have written. Okay, now the string which has exactly length 2, already I have written the regular expression. What is the regular expression I have written? I have written the regular expression as a plus b, a plus b. That is a regular expression for the string which has a length exactly equal to 2. So along with that, if you add this empty symbol, if you add this empty symbol, you will get the string length of 0, string length of 1, string length of 2. What I say is, when they ask you the regular expression which has a length less than or equal to 2, you have to write the regular expression which has the length exactly 2. What is the regular expression to accept a string which has the length exactly equal to 2? We have written in the last example, a plus b concatenated with a plus b. Along with that, if you add empty symbol, that is a epsilon symbol, that is, instead of a plus b, epsilon plus a plus b concatenated with epsilon plus a plus b. That is the thing what I'm going to write. Okay, you can see. Okay, in the previous example I had a length equal to 2, that is a plus b, a plus b alone I have written. Now if you want the less than or equal to 2 means, add epsilon symbol in both the places, empty plus a plus b, empty plus a plus b. It will give you the string length of 0, 1, 2. Okay, so that is a regular expression finally. So 2 times it is repeated, I can write it as epsilon plus a plus b, the whole square I can write it. One second. Now, the next question is, write a regular expression for the strings of A's and B's having a even length. Even length can be 0, 2, 4, 6. All the even numbers will be the even length string. Okay, so I'm just going to write a regular expression for the strings which has the even length. Possible even length strings are, I have written it as 0, 2, 4, 6. It goes on. Okay, now while to write a regular expression, you have to find out what is the first minimum even length. What is the first minimum even length? First minimum even length is 0. Okay, to write a regular expression with a 0 minimum string, we cannot do anything. Okay, whenever the minimum string in the given question is 0, with 0 we cannot proceed anything. So I have to go for considering the second minimum string. All possible even length strings I have written it as 0 A's, 2 A's, 4 A's, 6 A's. It goes on. Okay, the first minimum number of zeros are, minimum number of A's are 0. Okay, the first minimum string is 0 A's. Okay, with 0 A's I cannot write the regular expression. Not only here, with nothing in your hand you cannot proceed anything. Similarly, if the first minimum string is 0, from 0 we cannot proceed anything. We cannot start writing the regular expression. So whenever the first minimum string is 0, I have to go for considering the second minimum string. Now with 0 it is not possible to write a regular expression. So consider the second minimum string. What is the second minimum string? 2. two A's I have. Okay. Now two A's I have means two A's I have written. Okay. That is the string which has even length. Even length means the second minimum string is 2A's. Now what is a regular expression we have written to accept the string which has exactly length 2, which has exactly length 2? We have written a plus b the whole square is the regular expression what we have written to accept even that is to accept the string with the length 2. Okay. Okay, because why I'm considering this, 2A's means it is a length 2. Okay, the second minimum string is 2A's, that is length 2. So if I say the regular expression to accept the string which has the length 2, a plus b the whole square means it will accept only the string with length 2. It will accept only the string length with 2. Okay, it will accept only the string length with 2. But if I want to accept 4 A's, 6 A's, it should be repeated. Okay, if I write a plus b the whole square, if I write it a plus b the whole square, if I write it, it will accept only the string with the length 2 exactly. But even length means it should accept the 0 length also, it should accept 2 length, 4 length, 6 length, 8 length, it should go on. Okay, so this 2 I cannot write it. So what I will write means a plus b 2 times I have written. Okay, if I want to repeat it for 0 length, 2 length, 4 length, I have told you one more operator called hashtag. Okay, hashtag means 0 or more times it gets repeated. 0 or more times it gets repeated. For the first time, the hashtag value will be 0. If I apply value of hashtag as 0, 0 times these two a plus b's will appear, that is empty. If I apply hashtag value as 1, a plus b will appear once. Okay, if I apply hashtag value as 2, this a plus b will appear twice. So a plus b again one more time, a plus b it will appear. So if I want to have a regular expression for all the even length string, this regular expression for length 2 should be enclosed with hashtag, should be enclosed with hashtag. That is a regular expression for accepting the even length string. Now, odd length string. I have written the regular expression for the even length string. I have written even length string. I have written. Now, if I want to find the regular expression for the odd length string, means the odd length strings are 1, 3, 5, 7. 1, 3, 5, 7. In the even length string, the first minimum string is 0. So with 0, I cannot proceed anything. Okay. But in the odd length string, the minimum string is what? Minimum string is 1. But with 1 I can proceed. With 0 only I cannot proceed. But with 1 I can proceed. But if I proceed with 1, I will not be able to get the odd length. In the previous case, in the even length, 0 is the first minimum string. With 0 I cannot proceed anything. So I cannot proceed anything. So I just consider the second minimum string 2A's. Okay. But here in the odd length string, the minimum string is 1. Even though I have something in my hand, but still I am not able to do anything. That is a scenario here. Okay. In the previous case, nothing I was having in hand, I couldn't do anything. That is okay, valid. Something I have in my hand in the odd length string, but still I cannot proceed anything. That is waste. Okay. So instead of going for the considering the first minimum string as 1 is, what I will do is like, when you have asked for writing the regular expression for the odd length string, first write the regular expression for even length. Okay, this I told you. When you are about to construct a DFA for the negative case, first construct a positive case, convert that positive case into a negative case, I told you, right, in the first module. Similarly, when you have asked for writing the regular expression for odd length string, first write a regular expression for even length string. Now that even length string, you can convert it into a odd length string. That is a concept I am going to do. Okay. If you multiply even length string with one or more a's, then string will become one more A, then string will become odd length string. See, I have two A's. Okay, that is even length. Okay, if you concatenate one more symbol along with two A's. See, two A's are there. If I am multiplying two A's with one B, that even length will be converted into a odd length. Or two A's, which is a even length, if you multiply with one more A, it will get converted into a odd length. So similarly, what I'm going to do is I have a four A's here. You can see I have a four A's here. This is a even length string. Okay, now this, if I multiply with 1a extra, it will become the odd length. You can see totally I can write it as 5a's. Similarly, 4a's are the even length. If you concatenate one extra b, okay, this will become the odd length. So this concept I'm going to use. Now, what is the regular expression we have written it for the even length string? The regular expression what we have written it for a even length string is, one second. See, for a even length string, we have written the regular expression in the previous example is a plus b, the whole hash string we have written. Now, this is the even length. If you multiply this even length string regular expression with 1a or 1b, that gets converted into a odd length. Okay, I repeat, the even length string regular expression, what we have written in the previous example is a plus b, the whole hash string. If you multiply this even length string regular expression with 1a or 1b, it becomes a odd length. That is what I'm going to do. Okay, see, that is what I'm going to do. You can see. See, this is the even length. This, if you multiply with 1a, or r indicates a plus symbol. Plus means r. If you multiply this even length with 1a or 1b, this entire thing will become the the entire thing will become the odd length regular expression. Okay. See, when you get a question to write a regular expression for odd length string, write a regular expression for the even length. Along with that, you multiply or you concatenate 1a or 1b so that it becomes the odd length regular expression. That is a concept. Okay. Your next concept is, see, write a regular expression for the string which has the combination of a, b, c's. Condition is having at least one a and one b. Having at least one a and one b. That is a question. You need to write a regular expression for the strings of a, b, c with at least one a and at least one b. That is a concept. Now find out the minimum string from the given question. One a and one b. Okay, one a and one b. I'm just writing the minimum string from the given question. Condition is one a, one b. It can be a b or it can be b a. That is what I have written. It can be written as one a, one b is the condition. Based on the condition, I have written it as a b or b a. In whatever order you can write. There are two possible minimum strings. Take the first minimum string, that is AB. Okay. See, I have told you it should have one A and one B. I didn't tell you like where A should be, where B should be. And more than one A also it can be there. More than one B also it can be there. Minimum one A and one B should be there. Maximum any number of A's and any number of B's, any number of C's can be there. Now consider the first minimum string, that is AB. Now this A can be preceded by any number of A's or any number of B's or any number of C's. Okay. This A can be preceded by any number of A's or any number of B's or any number of C's. Okay. Now, this A can be again followed by any number of A's, any number of B's, any number of C's. Again, this B can be followed by same thing. Okay. That is what I'm going to write. Okay. Minimum, I need to have 1A and 1B. That 1A and 1B is there. Okay. 1A and 1B. As per the condition, it is there. And beyond that, it can have any number of A's, B's and C's. So any number means including empty. That's why I have enclosed with a asterisk. A or B or C, the total hashtag, and it can be followed by same thing, again B followed by same thing. Consider the second minimum string, that is BA. Again same thing. See, 1A should be there, it is present. 1B should be there, it is present. More than that, it can have any number of A's, B's and C's. Now this B can be preceded by any number of A's or any number of B's or any number of C's. Same thing, that B can be followed by same thing, and A can be followed by same thing. That is what I have written it. Now you have two options, right? And what is the regular expression you got for the first minimum string? This is a regular expression followed by plus followed by second minimum string regular expression. Okay, that is what I have grouped it together. You can see. Okay, you can see a regular expression for the first minimum string followed by plus symbol. Okay, followed by plus symbol. Regular expression for the second minimum string, that I have written it together, either this or this. Okay, so this is a regular expression for this particular question. Next question is, obtain a regular expression representing a language consisting of strings of A's and B's. See, obtain a regular expression representing a language consisting of strings of A's and B's with alternate A's and B's. That means A, B, A, B, A, B, it should be. Okay, it should not have A, A. Okay, alternatively A and B should be there. That means A, B, A, B can be there, or B, A, B, A. Alternatively, it should be there. And no two characters should be same. Okay, A should not be there, B should not be there, B should not be there. So the string what you consider, that should have the alternatively A's and B's, no same characters should be present next to each other. That is a condition. Okay, now you see example string. Okay, AB. The first string you consider here, AB is there, or you can consider BA. Okay, that you can get. Alternatively, you should have a A's and B's. These types of strings should be accepted. Yeah, okay, these kinds of strings should be accepted. If you have a string AAB, that should not be accepted, it should be rejected. Okay, now to accept, okay, to accept the AB's alternatively, how many times, if you consider this, the first string in the first example string, if you consider how many times AB is repeated, 3 times. Okay, whether it is compulsory that it has to be repeated 3 times, it can be repeated 0 times also. That is, there is no A, there is no B, that is also valid. 1A is there, 1B is there, 1A, 1B, 1A, 1B, it can be repeated. So AB can be repeated any number of times including 0 times. Okay, so here if I consider the first example string, AB can be repeated any number of times. Okay, so AB can be repeated any number of times means AB the whole hashtag. That means that if I apply hashtag value as 0, no A will be there, no B will be there, it is accepted. If I apply hashtag value as 1A, 1B. If I apply hashtag value as 2, AB will be repeated twice. AB for the first time, AB for the second time, it goes on. Now this is the regular expression for accepting this. Okay, now consider the second thing. How many times this BA is repeated? BA repeated. This BA repeated twice here. Okay, so BA the whole hashtag I have given. Here the whole hashtag I have given. Now it means that 0B 0A and BA, once it is repeated, second next value of hashtag is 2, means 2 times this will be repeated. Okay, it goes on. So AB the whole hashtag, BA the whole hashtag I have written based on these two example strings. Now see this minimum string, consider this minimum string, it can be preceded by, okay, it can be preceded by empty, okay, or B. It can be preceded by empty or B because it is starting with A. It can be preceded by what? It cannot be preceded by one more A, because if it is preceded by one more A, two A's will come, so there is no alternative B. Okay, so it can be preceded by nothing, or it can be preceded by the alternative character B. That is what I have written it here. This AB, the whole hash string, can be preceded by empty. Empty means nothing. Okay, and or there is a chance of getting B before this A. Okay, why I have not written A here? Because if I include A here, two characters will be same. There will not be alternative A's and B's. That is why I have written MT plus B followed by hashtag. And this AB hashtag, this B can be followed by what? B means what is the alternative character? A. It can be followed by A, or it cannot be followed by anything. So empty or A I have written. That is for first minimum string. Or means I have to use a plus symbol. I have used second minimum string. Now this second minimum string, the first character is B. This can be preceded by the alternative character A. It cannot be preceded by B. It will violate the condition present in the question. Okay. So or it cannot be preceded by anything. So that I have written as MT plus A. Now here this A can be followed by MT, or it can be followed by the alternative character B. So this is for this. This is a regular expression for the first minimum string, regular expression for the second minimum strings. Either this or that means I have to include the plus symbol. I have written it this or this. Okay, both will accept the question condition. So plus I have written. This is a regular expression for the given question. Now, this is a most frequently asked question, these type of questions. Write a regular expression for the write a regular expression for the string whose second symbol from the right end is A. Whose second symbol from the right end is A. That is a question. Okay. Now, I have taken two strings. Okay. Example string. See, the string can have a combination of A's and B's. There is no restrictions on any of the characters present in the string, but except the second character. From the right end means from the right. Okay, from the right side to the left side, from the right end, the second character should be A. That's all the condition what they have specified in the question. You can have any number of A's, any number of B's. From the third character onwards, the first character also can be anything, but make sure they have given the condition only on the second character from the right end. That should be A. So there are two example strings I have given. See, the string is starting with B from the right end, second is A. This is valid, and I am not worried about all the remaining characters. Now this string also, the string is starting with A, the second character is A. That is all my condition. Remaining character I am not worried. That means from the right end, the first character can be either A or B. Okay, from the right end, the first character can be either A or B. Second character should be A. So from the right end, the first character can be either A or B. That is true, because here it is A, here it is B. Anything it can be. The first character can be anything. That means only one character. Okay, because second character should be A, no? So the first character will be a single character, and second character should be compulsorily A. That I have written. And it can be preceded by any number of A's, any number of B's. Did I have any condition on these parts? No. First is like the first symbol can be A or B. Okay, as per this example, second character should be A from the right end. So these two conditions I have done. Okay, and from third character onwards, it can be empty also, it can have one character also, two character also, three, it goes on. So it can be a combination of A's and B's any number of times I can repeat. So A plus B, the whole hashtag I have written. This B or this A I have written. Second character is A, I have written it. And if you look at the remaining part, it is a combination of A's and B's. See here, A got repeated twice. Here B got repeated once. Here B got repeated thrice. So A's and B's can be repeated any number of times. So I have written it as A plus B, the whole hashtag. So this is a final expression for the given question whose second symbol from the right end is A. Similarly, if they say the symbol from the right end, that is the fifth symbol from the right end is A, means I have given the example also. 10th symbol from the right end is A. If they give, see, since second symbol is A, the first symbol can be A or B. Okay. Now if I say 10th symbol from the right end is A, this will be the 10th symbol. If you want this A to be the 10th symbol, this should be followed by how many A's and B's? It can be followed by 9. If it is followed by 9 A's and B's means, then only this A will become the 10th symbol. Okay, then only this will become the 10th symbol. Since this is the second symbol here in the previous example, since A is the second symbol from the right end, this is followed by 1A and 1B. Okay, but if you want this A to be the 10th symbol, this should be followed by 9 A's or 9 B's or combination of these two. Then only this A will become the 10th symbol. If I say it should be a 20th symbol, this A will be the 20th symbol means it should be followed by 19 A's or 19 B's or combination of those two. So I have written it as 9 here. If it is a 20th symbol, I will write it as 19. Okay, and it can be preceded by any number of A's and B's. That is a question. Okay. Now, one second. So many examples are there. Okay. We'll see this example. Write a regular expression to accept the language L is equal to A to the power n, B to the power n, where m plus n is even. That is, if you add the powers of A and B, the string should result in even. The string should result in even. Okay. So this is a question. Now for this question, I have to consider different cases. Case 1. Okay. Even number of A's. Even number of A's followed by even number of B's. You can see. Okay. See, the first case is if you have the n value as even, if you have the m value as even, the result is even. See, if I take n value as 2, m value as 2, m plus n is equal to 4. 4 is even, that is valid. So case 1 means even number of A's followed by even number of B's results in even number of symbols. Okay. Now, even means it starts with 0. With 0, I cannot proceed anything. So I will take second even number 2. Okay, so 2 A's the whole hashtag, 2 B's the whole hashtag. That is even number of A's with even number of B's. So second minimum even length is 2 A's and 2 B's, because 0 A's and 0 B I cannot proceed anything. So I have taken a second minimum even length, that is 2 A's and 2 B's. If I enclose this 2 A's and 2 B's with a hashtag symbol, it accepts 0, it accepts 2 A's, 4 A's, 6 A's, it goes on. And it is followed by again 0 B's, 2 B's, 4 B's, 6 B's, it goes on. Okay, that is a regular expression for the first case. Now, second thing is odd number of A's followed by odd number of B's will also give you the even length. Okay, odd number of A's followed by odd number of B's will also result in even. Okay, so that is the second case. Odd number of A's followed by odd number of B's results in even number of symbols. I'll tell you one thing. In the even length, 0 is a minimum string. With 0 I cannot proceed anything, so I have taken 2 A's and 2 B's. But in the odd number of A's followed by odd number of B's, the first minimum length is 1. That is, if I take n value as 3, m value as 3, 3 plus 3 will result in even, that is 6. Okay, but in the previous example, to write the regular expression for odd length string, I told you that write a even length string, convert that even length into a odd length, I told you. Okay, now already I have written for the even length. Okay, this I am just going to convert it into a odd length. Okay, how to convert? If these expressions are concatenated with one extra A and one extra B, I will get odd number of A's and odd number of B's. Odd number of A's, to get odd number of A's, even number of A's, that is A hashtag is the even number of A's, that if I concatenated with concatenate with 1A, it will end up with the odd number of A's. A hashtag, okay, and A, this is the odd number of A's. To get the odd number of B's, again this even number of B's, if you concatenate with one B extra, that will become the even number of odd number of B's. If you concatenate even number of B's with one extra B, that results in odd number of B's. Now this is the odd number of A's and this is the odd number of B's. If you add these two, you will get the even number of A's followed by even number of B's. Okay, see, that is what I'm going to write. AA hashtag followed by A followed by BB hashtag B. So based on two cases I have written. Okay, you combine these two regular expressions, that is case 1 regular expression, case 2 regular expression, that gives you the regular expression for the complete question. Okay, you can see regular expression is equal to the regular expression 1 plus regular expression 2, that is regular expression 1 is AA hashtag concatenate with BB hashtag. Second regular expression is AA hashtag followed by A, BB hashtag followed by B, that I have grouped it as a single regular expression. So this is a regular expression for your given question. With this I will wind up. See, this is one more example, very much important. The previous example and this current example is very important. You can see in the question paper also. Okay, so write a regular expression to accept the language A to the power n, B to the power m, where m is greater than or equal to 1 and n is greater than or equal to 1, where product of those two powers, in the previous case addition of those two powers should be even, I have given. Okay, but in this example the product of the power of A and power of B should be greater than or equal to 3. Okay, for this I need to write the regular expression. In this I have a regular expression for three cases. Okay, first case is, consider m value as 1, that is the minimum value of m is what, 1. Okay, and consider n is equal to greater than or equal to 3 means, see, if m is 1, with 1 if you multiply by what, you will get the product as 3. See, yeah, if I take m is 1, obviously n should be taken it as 3 at least minimum. You can take it as 4 also, 5 also, 6 also, but take the first minimum value of m is equal to 1 I have taken. Okay, take the take the minimum value of n, which gives you the product of, அதுக்கு அனிமேஷன்ஸ் கொடுத்துருக்கேன்,
நான் கண்டினியூ பண்றேன், ஒன்றும் பிரச்சனை இல்லை.
பரவாயில்லையா? ஏன்னா நான் பின்னாடி இருக்கிறதெல்லாம் படிக்கல. Okay, see, m is equal to 1 I have taken. With this m value, which n value if you multiply, you will get the product as 3. Okay, m is equal to 1 I have taken, n is equal to 3 I have to take, greater than or equal to 3 if I take, then only I will get the product as 3. Okay, so m is equal to 1, n is equal to greater than or equal to 3, and nm greater than or equal to 3. Now see, based on this, m indicates B. Okay, n indicates A. Okay, so what is the first minimum value of n? 3. Okay, so repeat 3 A's. Apply the first minimum value of n, that is 3. So if I apply A to the power 3, 3 A's will be repeated. Minimum 3 A should be there. Maximum it can go any number of A's. Minimum n is greater than or equal to 3 means n value should start with 3. Minimum 3, more than 3 also I can have. So 3 A's followed by any number of A's. That gives you the concept greater than or equal to 3. What is the m value? 1. 1 means b to the power 1. I will get single b. So this is the first regular expression for the case 1. Next case is, take the n value as, once again, in the second case, take the reverse of the first case. Take n value as 1. Take m value as greater than or equal to 3, so that product of these two will give you the value as greater than or equal to 3. Okay, 1 multiplied by 3, 3. 1 multiplied by 4, it is 4. So greater than 3 only it is. Now based on this condition, n means a. Okay. So what is the n value? 1. So a will be repeated once. What is the first minimum value of m? That is 3. What is the first minimum value of m? That is 3. Okay. So 3 b's can be followed by any number of b's. That is what I have written. N value is 1. 1a is getting repeated. Okay. 1a is getting repeated. And m value, the first minimum value of m is 3. Okay. So repeat 3 b's, and it can be more than 3 also. So repeat b 0 or more times. A followed by 3 b's followed by b has it. That is the second case regular expression. The third case is, take m value is greater than or equal to 2, n value is greater than or equal to 2. That is one case extra. Okay. Now first minimum value of m is what? 2. Okay. So that is 2 times I have to repeat b. Okay. First minimum value of m is 2. 2 times you repeat b. More than 2 also you can have. So 2 b's followed by b hashtag I'll be writing. First minimum value of n is also 2. So 2 times you have to minimum repeat a. Okay. And it can be followed by any number of a's. That is what I have written. First minimum value of m is 2, 2 a's. And it can be followed by 3 a's also, 4 a's also. To repeat, I have given a hashtag. First minimum value of n is 2. Okay. So 2 b's are there. Okay. That can be followed by 3 b's also, 4 b's also, whatever it is. So based on this condition, you write the regular expression. And if you combine all these three cases, you will get the final regular expressions for the given question. You can see regular expression is equal to the first regular expression or second regular expression or third regular expression. This is the thing. Okay. Now the question is, construct a regular expression, convert the given regular expression to the finite state machine. This is the next topic. So you will be given with a regular expression that should be converted into a uh, DFA or NFA or epsilon NFA, whatever is possible. Okay. See, this is a question. Obtain finite state machine for the regular expression a plus b the whole hashtag followed by 2a's followed by a plus b the whole hashtag. This is a question. Okay. Now, when you want to construct a finite state machine for the given regular expression, you need to make use of the Clean's theorem. You need to make use of the Clean's theorem. Okay. As for the Clean's theorem, we are going to construct a finite state machine for the given regular expression. Now, if you want to construct a regular expression for this, first you need to construct a regular expression for a plus b. Then you have to construct a regular finite state machine for a plus b the whole hashtag. Then construct for a, then a plus b the whole hashtag. Okay. So let us try for converting this a plus b the whole hashtag into a finite state machine. So the machine to accept a plus b means a or b. That is a concept. A or b is the concept. Either it has to accept a or it has to accept b. So parallelly I have to proceed. Okay. See, to process a single symbol. Okay. I need two states. To process a, I need two states. One symbol means two states. Okay. Two states, 2 and 3 I have. Okay. Connect these two. Write the first input symbol a on it. Okay. To process this b, either this or this means parallelly I have to proceed. Now to process this single b, I need again two more states, 4 and 5 I have taken. Connect these two and write the b on it. Okay, connect the b on it. Now either this or this means these two has to be connected on empty transition. These two diagrams should be connected on empty transition. So introduce one state in the beginning, introduce one state at the end. Okay, one state at the beginning, one state at the end I have introduced, because a or b should be connected. And connect this transition diagram on empty transition. Now 1 is a start state and 6 is a final state at present. Connect the state 1 to 2, 1 to 4 on empty transition. Okay. And 3 to 6, 5 to 6 you connect it on empty transition. Okay. This is for a plus b. This is for a plus b what I have done. Okay. Now I have to generate a finite state machine for a plus b the whole hashtag. This is the finite state machine for a plus b alone. I have to construct it for a plus b the whole hashtag. Okay. Now I have just copied the diagram. I have just copied this diagram in the next page. Now this finite state machine I am just going to convert to represent the finite state machine for a plus b the whole hashtag. Okay. So what I have to do means, to include this closure operator in the existing diagram, I have to introduce one more state at the beginning, one more state at the end. Okay. Whenever you connect something, okay, you have to introduce one state in the beginning also, one state at the end also. Connect those states on empty transition. Okay. In the previous case also you would have seen, see, after giving the transition diagram for A and B, to connect this A and B, I have introduced one state at the beginning and the one at the end, connected all the states on empty transition. The same diagram I have copied here. To perform this closure operator, again I have to introduce one state in the beginning, one state at the end, connect 0 to 1. Connect 0 to 1 on empty, connect 6 to 7 on empty. This I have done. Now this is not at over. Okay, after connecting the new start in the beginning, new state at the end, I have to give the transitions. This asterisk, if you want to include in this diagram, you need to give one reverse transition, one forward transition. That is, from this, okay, from this you have to give a transition, that is 6 to 1 on empty. This 6 to 1 on empty and 0 to 7 on empty, that represents this hashtag, that represents this hashtag based on the Clean's theorem. I repeat, if you want to give a transition for the closure operator, you have to introduce one state in the beginning, one state in the end, and you have to connect those states on empty transition to the next states. And this hashtag means the new states what you have created at the beginning, at the end, those states should be connected as a forward transition on empty. 0 to 7 you have to connect, and you have to connect the previous state 6 to the previous state 1 on empty. This is a reverse transition. These two transitions represents the closure operator, closure transition. Now this is the diagram for a plus b the whole hashtag. Remember where to give the transition on empty, 0 to 7 and the previous state to the previous state on empty. This is representing the a plus b the whole hashtag. And this should be followed by what? This should be followed by what? This should be followed by AA. Okay. A plus B. This is a transition diagram what I have constructed here. I have just took it as a snapshot. I have represented here. Okay, A plus B the whole hashtag representing this, and this should be followed by two A's. In the given question, A plus B the whole hashtag followed by two A's, followed by A plus B the whole hashtag. That is the question. Okay, now A plus B I have constructed. Now it should be followed by AA. Okay, how many symbols I have? Two symbols. That means I need a three states. Okay, two symbols means 2 plus 1, three states I need, including this 7 state to process A, including the 7, because this A plus B the whole hashtag should be connected to AA. So 7, 8, 9, three states I have taken. Okay, 7, 8, 9 I have taken. Now 7 to 8, 8 to 9 I have connected. Write AA on the transitions. Now I have done it for AA. Okay. Now this AA should be followed by again A plus B the whole hashtag. Okay. A plus B the whole hashtag followed by AA we have done. This AA should be followed by A plus B the whole hashtag again. Already I have constructed a finite state machine for the A plus B the whole hashtag. No need of doing it again. Just copy paste. Okay, A plus B the whole asterisk, same diagram I have copy pasted, but I have changed the numbers here. You can see the numbers are here 0 to 7, here 10 to 17, because it should be a continuous same state number you cannot give. So change the state number, and same thing state numbers I have changed it here. Okay, so A plus B the whole asterisk at the beginning, at the end it is there. Now this AA should be connected to this. What I have done, this is the end of AA, that I am just connecting it to the state 10 on empty. Okay, state 10 on empty. Now this is the complete finite state machine for the given regular expression A plus B the whole hashtag followed by AA followed by A plus B the whole hashtag. Okay, now this is the thing. So this is a regular expression. If you want, you can stop it. Now if you see this, how many times empty? See, 9 to 10 I have a empty transition. Again 10 to 11 also I have a empty transition. Two times empty transition is not required in the sequential order. This is also correct, but giving empty transition sequentially two times, it is not good. Okay, if you want, you can remove one empty transition, that is 9 to 10 I have, right? Instead of that, you can connect it to 9 to 11 directly. Instead of cancel this empty transition, okay, and connect, sorry, cancel this 10. Okay, cancel the state 10, remove the state 10, connect the state 9 to 11 directly. Okay, you can see I have removed, uh, it is not removed. If you want, you can do it once again. Instead of giving the two empty transitions sequentially more than once, remove the state 10, give a connection directly from the state 9 to 11 on empty, so that one empty transition will be removed. That is also correct, and this is also correct. Whichever you feel comfortable, you can follow. Okay, that's all about writing a constructing a finite state machine for the given regular expression using a Clean's theorem. See, with this, I will stop my teaching. I will hand over to the Jivita ma'am for proceeding the finite state machine to the regular expression. Thank you all.
Okay. Sorry. Yeah. So here, this next topic is your finite state machine to regular expression. Why it's not showing? 1 second. I'll drag this. Okay. So finite state machine to regular expression. Okay. So in the previous topics and all, you saw that we have constructed the regular expression to the regular expressions, and we can able to construct the regular expression to the final state, or from the you are going to convert it from the expression way of writing. From that you are going to convert into a diagram. Okay. So that for that you need to follow the Clean's theorem and all. You are going to follow the three models. What is that? The closure, concatenation property, and union property. These three property, if you know that, you can able to easily convert the regular expression to the diagrammatical thing. Okay. So for seeing only, it will be looks bigger and bigger diagram, but it will be very easy if you know these three models. Okay. Then in this we are going to convert in this finite state machine to regular expressions. We are going to convert into a uh, expression way of writing. The given will be your diagram. You need to convert into the expression way of writing. This expression way of writing is nothing but your regular expressions. Okay. So first in this we have some three cases. Okay. First initially three cases are there. These some several steps are there. You need to remember to convert into a regular expression way. Okay. So first what we are going to do, we are going to remove the unreachable states, intermediate states, and unwanted transitions or repeated transitions in the given diagram, and we are going to convert into a expression. Okay. This is the one thing. So if the machine does not have any final state, okay, if the machine does not have any final state, then directly you need not to see anything. You can directly write that it is null. The regular expression is null. Okay. If the machine has one single state, and one single state is your final state, start state, and the final state, then you can write directly it is empty. Okay. So if does not have any state, then you can able to write it as null. If you have one single state and that will be a start state, that will be the final state, then you can write it as empty. Okay. These three are the initial cases. Apart from that, we are going to create the three different cases. For three different cases, we are going to create a new state as a final state or a start state. Okay. New state we are going to create, and we are going to connect the new state by using the empty transitions. So which cases we are going to do that, I will tell you. So if the start state, okay, in the given diagram, if the start state has incoming edges, okay, if the state has incoming edges, then you need to create a new start state, and you need to name that transition as empty transition and connect it to the old state. Okay. So in that case you need to create. Then second case, if more than one final states are there, then we need to create a new final state and make the old final states are non-final state, and you give this final state, new final state, are the final state, is the final state. Okay. So for that also you need to connect the diagram by using the empty transition statement. Okay. So the second case when you are creating is, if you have more than one final state, you need to create one new state. That state will become your final state. All other non-final state which is already present there will become your non-final state. Okay. So this is your second case. In the third case, if there is only, 1 second, I'll move up this one. If there is only one final state and there are outgoing edges, so you have only one final state and there is outgoing edges. So in the first statement you saw that incoming edges in the start state you are going to create. Here in the final state, outgoing edges if it is there, then you are going to create. Okay. So then you are going to create a new final state and make that old state as a non-final state, and make this new final state as a final state. Okay, by using the empty transition. So these six conditions, these almost five conditions are the basic, and you need to follow the conditions. Apart from that, there are some steps which you can able to uh, you have to think and do. Okay, so apart from that, there is nothing to remember in this steps. After doing all these, you are going to remove the unreachable states. You are going to remove the intermediate states in the given diagram. Okay, so in the given diagram, suppose if you have some five states. Okay, the start state, from the start state and the final state, you in between we have q2, q1 and q3. Okay, suppose you have three more other state as a in between state. These states will be considered as intermediate states. So you need to remove this one after another. You need to take it out all the transition and combine those transition as a single. Okay, so finally you will be reaching to start state and the final state, and in between you will be having, when you are combining all the states, you will be combining its own transitions also. Okay, by having the properties, and by having the properties of the regular expression, you are going to combine the inputs. Okay, so when you are combining all the inputs, you will be getting some precise regular expression kind of formula. Okay, then at last you need to remove the start state and the final state. You will be reaching the regular expression. Okay, so we'll solve one problem, then you'll be understanding these steps. You need not to memorize. The five first steps are important, and you need to write that as a steps to convert into a regular expression. It is an algorithm, or it is a step. You can take it. So this question is asked in our model paper also, and it is an university question also. Okay, the transitions they have given, there are three states, 1, 2 and 3, and two input alphabets A and B. Okay, and they've given the transitions in the transition table. Okay, so if they given the table, you need to convert into a diagram. So from the diagram, from FSM, we are going to convert into a regular expression formula. Okay, so which is so if you convert the table in terms of diagram, you will be getting a diagram like this. As I already told you, if you have three states, you take it as a triangular structure. Okay, so triangular structure we have taken, one on the input of A, it goes to 2, two on the input of A, it goes to 3, 3 on the input of A, it goes itself, loop itself, so it is a loop. So like that we have made the diagram. Okay, so let's see how we can able to remove it step by step to reach the regular expression. Okay, so initially we have the three different states. Okay, so here what is the first condition? If the start state has the incoming edges, if the start state has the incoming edges, then you need to create a new start state, right? If the final state has the outgoing edges also, you need to create, and more than two final state, that is the second step. So step by step we will go. So what is the first step? If the start state contains a new final state, you are going to create a new start state. Okay, so here the start state is 1. Okay, for 1, the incoming edges are B. Edge is nothing but a transition, the arc is called as edge, right? So here there are two incoming edges which is coming to 1. So the start state contains incoming edges. So we are creating a new start state and connecting that new start state to the diagram by using the epsilon transition, empty transition. Okay, so this is the first step. Then if the diagram contains, if it is containing two final state, more than one final state, which is 2 or 3 or 4, any number of final states, more than one if it is containing, then you need to create one new final state, right? That is the second case. That is the second case. So we are creating here, yes, in this diagram we have, this is one final state and another final state. There are two final state. Okay, so we are going to connect this to the new final state which has been created now. Okay, so we have created one new final state and connect this one and this two to a empty transition by using a empty transition. Okay, so by using epsilon, I am connecting this one to new final state and two to new final state, so that I am making this final state 1 and final state 2 as non-final state. So it becomes a normal state in the, it should become a normal state in the next diagram. So this is, this, it should not contain two circles, but I think the diagram is not changed. So it should not have a two circles. This is a normal state as like other state. Okay. Then and then we need to, what is the third case? If it is containing any incoming, this is the final state. If it is containing any incoming edges, we need to do that. So apart from that, no, there is no other condition. So we have start state and final state. Okay, these are all your intermediate states. Okay, now we are going to remove the intermediate states one by one by combining all the transitions. Okay, so initially we are going to remove the number 3, number 2, number 1, and then we will be having start state and final state. Then we will be having the regular expressions. Okay, so so we are going to remove the number 3 state. Okay, so if you remove the number 3 state, what their transitions you need to combine. Okay, so what is the transition it is giving? From 2, by accepting a, it is going to 3, and 3, in 3 we have a loop. Okay, so after accepting a, then a loop, how you will be writing a loop in the regular expression, in a expression way. In a expression way, it will be written as a star. Okay, so many number of a, we will be writing it as a star. So after accepting a star, and accepting b, it goes to 1. Okay, so we, by removing this, I am going to combine these many transitions. Okay, so after accepting a from 2 to 3 and 3 to 1, it is accepting a star and b. Okay, so I can write this as one transition by removing this. Okay, so how I can write this? So I've written one single transition. Okay, after this you can see that from 2, there are two outgoing edges which is going to 1. Okay, so how I can travel to 1? Either by using b, I can go to 1. Okay, or I can use by accepting a star b, I can go to 1. Okay, so there are two outgoing edges to 1 from 2. Okay, from 2 to 1, there are two transitions. So I'm going to combine these two transition by writing the formula like b, either by accepting b or this statement. R means we have to use plus. Okay, R means we have to use plus in the regular expression. So how to write this? B R a star b. Okay, so b r a star b you will be writing. So from 2 B R A S R B. Okay, you are writing this. So apart from that, we have these many transitions. After combining this, removing this 3 and combining all the transitions, we have these many. Now we are going to target for 2. Okay, now we are going to remove the intermediate state 2. If you remove this state, what and all the transitions are there, we are going to combine and put into A. Okay, so how it is traveling to A? By accepting A and accepting, and back it has to accept b plus a star b, it goes to 1. So it is a loop, right? So it is going to a, coming to 1, going to a, coming to 1. So it is a loop. Okay, so we have to show it as a loop in the state 1. Okay, so able to see that by accepting a, it goes to 2. Again by accepting this regular expression, it goes to 1. Okay, so it is a loop. Okay, and also the other way, if I remove this, I can able to from the state 2, I can travel to final state also. Okay, how? After accepting A, either I can come to 1 back, or I can go to the final state also. Okay, so I need to show this transition also, and I need to show this loop also. Okay, if I'm removing this state 2. Okay, able to understand? So if I'm removing this, I need to show these many transitions. So from 1 to 2 to 4. So 1 to 4, if you are combining this A and then accepting empty. So A and then accepting empty, which is equal to A only. A empty, which is equal to A in the regular expression by the formula. Okay. So we are going to write it as a A and to the final state. From 1 to final state, by accepting A and then empty, it is coming. So instead of writing A empty, I am writing A transition to non-final state. Okay. So it is by combining this one thing I can able to remove. So this thing, if I want to remove, I need to combine this as a loop. So I am going to introduce one loop. In that loop, what I am going to give? A followed by this statement, B or A star B. It is a loop. Since it is a loop, it can appear any number of times. So any number of time means it is represented in the regular expression. You need to represent it through by star. Okay. In the regular expression, but in the diagram you are going to represent it by uh, self loop. Okay. Okay. So in the self loop, we need to show if you are removing the number 2. Okay. So in the self loop, the formula, whatever you have written, you are going to write. Remove the state, remove the transition between 1 and 2, and remove the state, because we have introduced the self loop. Now there is only one in between state, which is intermediate between the start and the final. We are going to remove this. If you remove this, what do you need to combine? This is your empty, and we have A here and we have empty here. So empty and loop of this, then followed by either epsilon or by A, you can able to come. So from 1 to final state, how you can travel? Either by accepting A or not and. Either by accepting A or epsilon. Okay, it is not and, it is R. So R means how you have to write it? Plus symbol. Okay, so it is epsilon plus A. Okay, so you can combine these two transition by writing A or epsilon. Okay, so I'm removing this, and I'm going to write the regular expression as A or epsilon. Okay, removed two transition and combined as one transition. Able to understand? So now I'm going to remove this intermediate state also. So if I remove this intermediate state, I'm going to combine all these. All these I need to combine. So how I'll combine? Empty A, B plus A or B. Here whole star will come. Whole star will come because we are removing the loop. If you remove the loop, in the formula kind, it should be written as many times. Many times means star will come. So whole star will come here, followed by A or epsilon. Okay. So this is the regular expression we got finally. Then automatically you can remove this and remove this. This is the final regular expression we got. So so here, since we are removing this here whole star will come. Okay, that's all. That is the only change. So apart from that, you can able to remove the thing, and the final regular expression is empty A star. Here star will come, and then followed by this. you can able to remove empty. Empty if it is there also same meaning, empty if it is not there also same meaning. In the multiplication it is like one only, right? This is like concatenation. If it is r is there, some meaning is there, otherwise there is no meaning. You can write or you may not write, there is no value in that. Okay, able to understand? Any doubts in this? So next one is regular grammars and regular languages. Okay. So what is regular grammar? The languages, whatever we are seeing, the languages are nothing but to communicate to the machine. We need a languages. Okay. So from where these languages are generated? From the grammar. Okay. So regular languages is a language which is accepted by your finite automata. So from where it is generated? It is generated from the regular grammar. So each and every languages which is generated from a grammar. Okay, it has some construction, it has some tuples, some variables, some formula. We have what are all the tuples for the regular expressions? Nothing but there are four tuples. It will be following V, T, P, S. V is a set of non-terminals, T is a set of terminals, and P is a productions, and S is nothing but your start symbols. Okay, so this basically for all the grammars we will be following this set of grammars. There will be small changes here and there in the writing of productions, but tuples mostly it will be same only for all the set of grammars. There are different type of grammars. We will it is there in our automata subject. Okay, so the finite state machine is a machine which accepts the language from a regular language and the regular grammar. It does not know any other languages. Okay, so if the grammars are generated from this regular languages, then it will be accepted, and it will, you can able to design the languages. So far we saw that regular languages only. Okay, so in the so here that the productions will be of the form, here they have given the form. The production will be of the form alpha gives beta. You need to write the production. The grammar statements will be written in this format. Okay. So alpha is the string which is developed, which is you can able to write the string with the combination of V union T. Okay. So V is a non-terminal, T is a terminal. Okay, so terminals are smaller case letters. Basically, in our book, we are following only few terminals. Just you remember those terminals only. The symbols are terminals. Smaller case A, B, C, D are the terminals, and 0, 1 are the terminals. Okay, non-terminals will come in capital letters always, which can be S, which can be X, Y, Z, like that will comes in our AB also, capital letter AB, like that non-terminals will come. So capital letters are non-terminals, smaller case letters are terminals, and productions will be represented as P. Then production will be of the form alpha tends to beta. Okay, so here the string alpha, which can be formed with V union T whole plus we have given. The beta can be produced with the help of V union T whole star. So what is the difference? Here it is plus, here it is star. Star means one or many, plus means zero or many. Okay. So zero means it accepts null also. So which can be null? Beta can be null. So where beta is there in the right hand side of the production. So in the right hand side of the production, null will be accepted, empty will be accepted. But in the left hand side of the production, empty will not be accepted. That is the definition of this regular grammar. Okay. So who has developed this all these grammars? Chomsky hierarchy has developed. He has developed some 4 different type of grammar: type 0, type 1, type 2, and type 3. We will see that grammar and what is the definitions for that quickly. Okay, so type 0 grammar is otherwise called a space structured grammar, which has, as I already told you, all the grammars will have the same tuples, VTPS. Okay, but the writing of productions will vary. Okay, so alpha will be V union T plus, and beta will be V union T star. There is no difference in regular grammar. This one type 0 grammar, uh, and this both are same only. So there is no restriction in the length of alpha and beta. So you can able to have n number of length for the alpha also for the right hand side and for the left hand side also. Okay. So in some grammar there will be restrictions. So that's why they are mentioning this point. Here there is no restrictions in the length of alpha and beta. So, and what is the another condition? Alpha cannot be null. Okay, which means here it plus is given, so alpha cannot be null. Here star is given, so beta can be null. Okay, so that is one more difference. And what language it will accept? The language generated by this grammar will be the language called recursively enumerable language. We will be calling it as recursively enumerable language. Okay, who will accept this? The Turing machine will accept this. Okay, so a grammar which is produced by regular language, which will be accepted by finite automata. We all know that because we saw that in the first module, right? The language which is generated from the regular grammar is called as regular language, which is accepted by which machine? Turing, finite automata machine, finite state machine. Okay, the language which is generated by type 0 is called as regular recursively enumerable language, and this will be accepted by Turing machine. Okay, so example productions, grammar productions they have given. So in the left hand side can be null, but the right hand side should not be null. And here any number of characters you can able to have in the right hand side and in the left hand side. Okay, then type 1 grammar. So in type 1 grammar is called as context sensitive grammar. Okay, context sensitive grammar, it has restrictions on the beta. It has restrictions on the beta. Beta should be greater than or equal to alpha. Always beta should be greater than or equal to alpha. If it is 1, at least 1 should be there in the left hand side. Right hand side. If the left hand side is 2, it should be, it can be 2. Okay, but it should not be lesser than that. That is the condition. Okay, so beta should be greater than or equal to alpha. The length of beta should be greater than or equal to alpha. Where beta comes? Beta is in the right hand side, alpha is in the left hand side. Okay, this is the condition. So alpha beta that belongs to V union T union. Both cannot be null. Both the side, here it is plus. Alpha and beta both they are given it as plus, which means both cannot be null. Empty will never come in the context sensitive grammar. Okay, so empty cannot appear in the left hand side or right hand side of any productions. Okay, so we can call this as empty free grammar also. Since empty is not coming, empty free grammar also we can call. Then context sensitive language which is accepted by the linear bounded automata. Which automata will accept? Linear bound automata will accept context sensitive language. Okay, and some example grammars here they have given without empty. You can see that without empty, and right hand side is more or equal to the left hand side. Here one symbol, here three symbol. Yes, it is possible. Here two symbol, here three. Here two, here also two. So it is possible. Type 2 grammar. So in type 2 grammar, we can call it as a context free grammar, CFG. Okay, this we are seeing in the second module only, right? Second or third module. Then this grammar we can call it as a type 2 grammar, and here it has a condition in the production itself. So here alpha gives beta. In all other productions, this is alpha gives beta, but here a non-terminal which produce definitely right left hand side should be a non-terminal. Okay, a non-terminal which produce the combination of terminal or non-terminal in the right hand side. Right hand side there is no restriction, but the left hand side only there should be the who has to produce the grammar, only a non-terminal has to produce. Okay, so that is the condition. And star is given for alpha, so empty also it will accept. That means empty also it will accept. A is a non-terminal, and here context free language which is accepted by the push down automata. This push down automata will comes in our fourth module. So push down automata it will accept. The example for this is you can see the left hand side of the production is single non-terminal. It should be single non-terminal, followed by the right hand side can be combination of lowercase and uppercase, or it is empty. Okay, lowercase, uppercase, or it is empty. This is the type 2. Then type 3 is our known grammar, which is regular grammar, which we saw in the first module, which we used in the first module, right? So see, G, it has 4 tuples, and here we have the regular grammar. A gives WB, where W is terminals, okay? So it should start with a terminal. The right hand side should start with a terminal followed by the non-terminal, or only a terminal. That is the condition. Okay. So here, as like your context free grammar, the left hand side should be your non-terminal. A single non-terminal will produce a grammar followed by the followed by a and any set of like any non-terminal smaller case letters followed by capital letters. That is what it is represented. B W B. W is nothing but terminals, set of terminals. It can be null also. Okay. So empty also it will accept, but a single terminal it can be, or terminal followed by non-terminal can come. But in the right hand side, immediately non-terminal should not come. Okay. That is the condition of the regular language. So regular language, we know that which automata will accept regular language. Our finite automata will accept the regular language. So you can see the examples. Yes is a single non-terminal which is producing AAB. So beginning, starting should be a terminal followed by non-terminal can come. Starting should be a terminal. Here also starting should be a terminal, or it can be single terminal, or it can be empty. But immediately after this, immediately capital letter, if it comes in the right hand side, then it is not a fine regular language. Okay. So these are all the 4 different grammars we saw. Then finite automata to grammar. So how we can able to convert the from given diagram, if some automata is given, you need to convert into a grammar. How you can able to convert into a grammar? Either by thinking logically, you can able to convert into a grammar, or you can able to convert into a DFA method, or by using a regular expression method, you can able to convert into a grammar. So what is grammar? Grammar is the production way of writing. A is giving B. A tends to B. B tends to A. C tends to A. So like that, the production way of writing is called as grammar. What is expression? A formula kind of writing is called as expression. Okay. If you are drawing a diagram, then it is called as finite state, finite state machine, or FA, we can finite automata, something like that. So from anything you have, you should know to convert from anywhere, because all are accepting the same language. Okay, all are accepting the same language. From if the regular expression is given, you know to convert into a diagram. If the diagram is given, you should know to convert into a production way of writing or expression way of writing, because all are accepting the same language. Okay, but their way of writing will be different, but all are accepting the same language. Okay, so that's why these many conversions we are studying in our subject. Okay, so these are all the some steps we have. We'll see one example. Obtain a grammar to generate a string consists of any number of A's. Consist of any number of A's means it can be 0 also, it can be null also. So first state in that we can give the loop of A. Okay, the loop of A represent that many number of A. Okay, it can be 0 also, it can be 0 also, it can be many number of 1 also. So first state will become the final state also here. Okay, so this method will, we are converting a grammar from the DFA. Okay, this is not a logical method. By thinking also, without the DFA, you can able to convert. Okay, so we will see that also. So here, so first initially, whatever the given question, you need to draw the DFA. From the DFA, you need to take what are all the transitions are there. So S is the final transition, S is the start state, and S is the final state also. And the grammar here for that, you need to write it as What is the transition? Transition of S on the input of A, it goes to S. This is the only transition we have in the DFE, right? Is there any other transition? No, right? So we have only one transition, okay? So for this transition, what is the grammar we need to generate always? If whatever the final state you have, for that final state, you need to generate one empty transition, okay? So in if you are having a DFA which is containing Q2 is a final state, then you need to create a final state for the Q2, okay? So if A is a final state, you need to create A gives epsilon, okay? If B is a final state, you need to create B gives epsilon. So here S is a final state, so by default you need to create this one first step of grammar. S gives epsilon. Apart from that, by seeing the transitions, you need to convert into the grammar. So what is the transition? S is giving A, S on the input of A, it is goes to yes. So how to write that? Input, you are going to write it in the right hand side of the production. From yes, after accepting A, it goes to yes. After accepting yes, it goes to yes. Okay. Language generated by the grammar can be written. So here the language generated, we can able to write in the language format. How you can write within the set notation? You need to write that what is the input we are accepting n number of a. Okay. So a to the power n. So what is n? N can be greater than or equal to 0. It can be 0 also, 1 also, 2 also. So that is why that's what we have showed in the language format also. After that, you need to write in the conclusion language format. Here, what are all the different type of strings it will be accepted by this language. So a power 0, which is nothing but empty, then followed by single number of a, two number of a, three number of a's, and it goes on. So it accepts all the different languages. Okay. So generator string consists of at least two A's, okay, by logical method, okay, at least two A's and many number of A's. At least two A means here the mandatory case. You can able to show that mandatory case is A, okay. At least two A it should be there. After that, it can be three number of a, it can be four number of a, five number of a, it goes on, okay. What is the mandatory case? A is the mandatory case. So when you are designing the DFA, first always you should design for the mandatory case. Must and should case only you will design. You will design for the skeleton first, and then you will show the other transitions, okay. Similar way, here while designing our grammar also, first you should design for the must case. Okay, the must case is here AA is the must case. So S gives AA we have written. After that, maximum can be any number of A's. What is the maximum? Other cases, any number of case. Any number of case means it is a loop. So loop means how you can able to show the loop. In the previous example, we show the loop by S gives AS. It is a loop. Loop means the starting and the right hand side, the ending grammar symbol should be same. How you should show the loop? The starting symbol, which means left hand side and the right hand side, the ending symbol should be same. So yes gives, and what it is going to produce in a loop? A it is going to produce in a loop. So we need to write it as A. S is giving A, yes. So starting symbol and the ending symbol are same, and what it is going to be produced repeatedly? A it is going to produce repeatedly. If suppose AB is going to be repeated, then you have to write it as AB and followed by S. So self transition and the loops will be represented like this. Okay. So these two are the transitions. Or you can able to write this by using a symbol, pipe symbol. This pipe symbol represent the R statement. Okay. So S is giving same, S is giving same, yes, right? So I can write it as S is giving AA or AS, either this or this. I can able to write this two grammar statements I can able to combine by using pipe symbol if the right hand side, if the left hand side of the production is producing the same symbols. If AA is there, I can combine AA. If SS is there, I can combine SS. So like that, you can able to write. Okay. So language generated by this grammar is L is equal to A power N, where N here is minimum cases equal to 2. So that's why N greater than or equal to 2. It can be maximum cases many. Okay. Time up. You should wind up. Slides. We are in 40. 6 slides only. I'll finish it off. There are more than 6 slides. I'll finish it off. Now only time is 4 o'clock. And another 15 minutes. Okay. So next one is generating string consists of even number of A's. So even number of A's means it should be 0, 2, 4, 6 will be the even number of A's. 0 number of A's, 2 number of A's, or 4 number of A's. Okay. Since it is 0, 0 is given means it accepts empty. So directly you can write without seeing anything, you can write this statement. S gives empty. Okay. S is accepting empty. For 2 number of A's, we can able to write as like the previous problem. S gives AA. So S gives AA. This you can see that it is multiples of 2A. Okay. So 2 power again, if you repeat this 2 times, we will be getting 4A's. If you repeat this 3 times, we will be getting 6A's. So it is repetition of this. Repetition, for repetition, what you have to write? You have to include a start state and at the end also the same state. If you repeat, it is a loop. Okay. So it is twos, loop in twice, loops twice. So you have to write, since AA we are repeating, we have to write that as, subsequently we can able to write it as S gives AAS. Okay. Since it is a loop, we are writing whatever comes in a loop, we have to write in between. Okay. So start state and this ending will be the same, and in between what is repeating, that should come in between, in the middle. This is the way of writing a loop. Okay. So if you want to, if you don't want this table, if you are giving A, and here also A should come. If you are giving B, here also B should come. So this is a way of writing a loop. Then modulus mod 3 greater than 0. Okay. So here a language which accepts W, that the length of W, the string W should be mod 3, that should be greater than 0. Here if they given equal to 0, then it is the length of the string should be divisible by 3. Okay. Which means that we come to know that it is, it can be, the length of the string can be 0, the length of the string it can be 3, 6, or it can be 9, like that, multiples of 3. But here they have given it is greater than 0. Okay. So when mod 3 will be greater than 0, if you have 4 number of 4 is the length of the W, 4 is the length of the W, then if you divide by 3, you will be getting a remainder 1. So that is greater than 0. So this automata will accept 4 number of A's and 5 number of A's, 6 it will not accept. Then 7 number of A's, 8 number of A's, 9 it will not accept. Okay. So whichever is greater than 0, it will accept. The multiples of 3 it will not accept. It should not accept. Okay. So that is the case we are going to design. So these are all the things we are, you can able to write the DFA diagram. From the diagram also you can convert, or you can think it logically and then you can convert. Okay. Where here W can be formed by using A. it is not A or B, it is W can be formed with A. Okay. So only A is enough. So modulus of A is 1 means it is greater than 0. So it will be accepted. One number of A will be accepted. Then two number of A will be accepted. Okay. And three number of A's it should not accept. And three number of A's it should not accept. So so we can able to write that yes, one number of A accepted. Yes can produce two number of A. Yes should not produce three number of A's. Okay. So if it is three number of A, along with that, if you join one A or two A, then it will accept. Okay. So along with three, if you add one more A, it will become four number of A. So it can accept. Along with the 3, if you join 2 number of A, it becomes 5 number of A. So it will be accepted. But alone S is producing A should not be accepted. So how we can able to write this? S is we can able to at last, if you attach this, then you can able to write this. So we have to show that the transition after the three number of A, we have to attach one A or two A's. Okay, this one A or two A, either we should not write like this in the productions. We should write it in a simpler manner. For that, you can substitute the non-terminal, whatever it is coming here, in the transition. Okay, so S is producing A. Yes, you can able to write it here. Okay, so for this, the finally you can able to get two transition. S is producing single A, double A. S is producing after three number of A. Either this will come or this will come. Then only it will accept. Otherwise, it will not accept. Okay, so like this you can able to convert grammar from the regular expression. Sometimes they will give you the regular expression and ask you to find the grammar. Okay, so they will give you the diagram and ask you to find the grammar also. They'll give you the regular expression and ask you to find the grammar also. Okay, so for that also it is very simple. Here regular expression, if it is given, what is the mandatory case? We have to keep the mandatory case as it is. Okay, so here AB is the must. Okay, so in this AB pattern should come in the substring, should come as a substring. This is a grammar will accept the language of strings which is producing A and B having a substring of AB. Okay, so AB is a mandatory case. Okay, so for this you need to keep it as it is. Okay, so here what is given? A or B whole star. So we cannot assure that which will come in the beginning. Okay, if I am the user, I can able to give A. Okay, if you are the user, you may give as B. I will give two number of A or three number of A. You may be giving three number of B or two number of B. Anything can come, right? We cannot give surety. For this, for such a kind of regular expression, you need to substitute the non-terminals. Okay, this is like a rule you have to remember. For the must case, you can keep as it is. For the if you are not sure about what will come in the string, okay, either this or many number of loops, star if it is there, for those cases you need to substitute a non-terminal. Okay, so the non-terminals are capital letter. So here S is a start which is producing. Always our grammar you will be using the start symbol S only. Okay, so S which is producing. For this I am using a non-terminal A. Okay, so since the A, B or whole star is repeating at the back also, I am substituting the same non-terminal again. Okay, so instead of repeating the different non-terminals, we can substitute the same non-terminal again because both are same only. So in between I have the must case. So I'm keeping the same as it is. Okay. So after that, this is your so this is your automata. For that, grammar. For this A, we need to define what is A in the production. So what is A in the production? Either A or B. So either A or B means how to show in the production? Either A or B whole star. So it is a loop. Any number of A or B in a loop. So any number of A or B, A loop or B loop, or it can be empty. Star represent, this star represent empty also. Nothing. If A also not coming and B also not coming, then directly AB will process. It represents null also, right? So this, for this A, we are defining empty followed by A loop. It can be A loop or it can be B loop. So why I'm saying it is a loop? Starting with A and ending with A. If you write this production step by step, which means if you divide and write, split and write, it is three productions, right? This three productions separate production A. A only is giving produce this loop, A is giving B loop. Okay. What is the production? A S is producing A, B, A. This is the final production. And this is one more problem. One more problem, which is okay. Number of A, okay. Number of A in W mod 2, okay. So here A and B, it is combination of A and B, but number of A in the W, there is a condition, okay. So number of A only has a condition, B can be any in number, okay. Mod 2 should be equal to 0, which means multiples of 2, it should be multiples of 2. So already we have designed for multiples of 2, okay. So A whole star is the condition, followed by B can be anything, okay. So what is the regular expression for this? We can able to see here, in this problem we designed the uh, uh, production by using the regular expression, okay. So what is the regular expression for this? It is A multiples of A, so A star, okay. So this I can able to in between, B can become in the beginning or at the end or in the middle, okay. So B can be, there is no condition for B, so B star can come here, or can come here. So if you expand and write B star A, B star A, B star whole star, because A is repeated for multiples of 2, okay. So it is a loop, so A should be multiples of 2. So multiples of 2 means 0 also included, that's why we are writing star, okay. So 0, 2 number of A, 4 number of A and A. And in between anywhere B can come. Okay. So here whenever the must case, you are taking the must case directly, and for n number of loop cases, or if you are not sure how many times it will come, you are going to take it as capital letter. So that capital letter is nothing but your non-terminal. So B I'm going to take the whole thing, the whole regular expression itself, I'm going to repeat it for many number of times. So if you are going to repeat it for many number of times, again you are going to substitute a non-terminal. So you should remember, if star comes, you are going to substitute a non-terminal. If you are not sure what comes, you are going to substitute a non-terminal. If you are sure the must case, mandatory case, you are going to keep it as it is. Okay. So what is my production? S will be empty because it accepts null also. So S can be empty, or S can be A followed by, it is a loop, because A is containing star. So star means it is a loop. So A, yes. So why I'm giving S as a loop? Because starting production is yes. So ending also yes, then only it is a loop. Followed by, I need to define what is A. So what is A? B whole star. So B is the production. Whatever we have designed here, that we have written. Then what is B? B is nothing but B loop. B can be empty and B can be loop. So empty also, and it can be a loop also. So that is what
and we have given this pumping lemma is there last slide. Okay, this I will start in the next class beginning. One student has asked, I'll start freshly in the next class, pumping lemma theorem. Okay. So up to this module 2 topics almost we have covered.
That's all. Pumping lemma is left out.
Pumping lemma is left out. Students today morning only they have asked, so I have added that in a slide. I will explain in the next class. Okay. Tomorrow's session. Thank you all. Please do attend and utilize. Thank you.
Thank you all for attending today's webinar on ATC. Thank you so much. We'll continue the third module and the fourth module by tomorrow. Okay. So thank you all for participating. Shividya ma'am. Shividya ma'am. SVR ma'am.
Yeah, Devi ma'am.
Can we wind up, ma'am?
Yeah. You can ask them if they need any doubt clearance or whatever.
No, actually, they wanted to share the PPTs and the videos, whatever we have sent, that recorded video. And whatever questions they have asked them, we have answered then and there only. So other than that, they don't have any other issues.
The video will be available on YouTube. Okay, so it's live streaming on YouTube. Anyway, once the people finish everything, the rest of the sessions also will post it on WhatsApp group. They have joined the WhatsApp group, right?
Yeah. We also told that PPTs will share at the end of the session, like the tutor session. Okay.
Yes, because anyway, after this, they're not going to go and study immediately. So let them finish this one tomorrow presentation. Afterwards, we will surely share the PPT. Not a problem. In the WhatsApp group, as well as for our students, we can post it in the individual groups also. No problem.
Yeah. Thank you for administrating all the works today, ma'am. Thank you so much.
No problem. It's a pleasure. Let's meet tomorrow again. Okay.
Yes, ma'am. Thank you, ma'am.
Thank you, ma'am. We have disturbed you on Sunday also. Thank you so much.
Ma'am, please provide solution of model paper. Okay. PPTs for the other college. Yeah, don't worry. You're there in the WhatsApp group, right? I will share it to you in the WhatsApp group. Okay. Why is it that you're not on the WhatsApp group? Some people are telling you're not in the WhatsApp group. If the link for the WhatsApp group would have been sent to the registered email ID, and tomorrow morning I will post it once again. Okay, or just hold in for a minute. I can post the WhatsApp this one now. Just a couple of minutes, Jivita ma'am. I will just post it. Yeah. Wait 1 minute. I'll post it. Yeah, just give me a minute.